Great. I know today's speakers are wonderful and the topics are also going to be great. By the way, I'm Padma Ayala. Those who do not know me, I'm the founder of this community. Somebody was asking me, it all started in 2021, post COVID, just to create a $0 platform for people to come, network, learn, grow, thrive. That's all. So, but even though that is what the original intention, we are growing. We are growing by numbers, which I think, what are the upcoming events, all that I think Chitra is going to give those details. So I don't want to bore you guys. But what are the things that my vision, why am I doing this is like, one course. Back in India, this is I'm talking about many, 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 many centuries ago. The Takshashila and Nalanda, there are two universities. The first university was Takshashila. People from all over the world used to come and discuss, and such open discussions will create innovation. And I want that to come to here. I want the Seattle, Bellevue to be the new Takshashilas. So with that in mind, we have started, and so we want variety of topics as long as it's data AI security. Anyway, in the last 6 months, I traveled to India. I was working with the Indian government on capacity building for India. Even there, everybody has the same thing. Hey, AI is exploding. How to govern it? How to build responsible AI solutions. So, in any part of the world, it is the same questions that people are thinking, and that is what our speakers are going to talk today. So, thank you, Walter. Thank you, Ken. Thank you, Vikas, for taking time and sharing your knowledge. The other thing that I just told, I'm working with the University of Washington, University of Dallas, GSU, and the Govs to start some cybersecurity labs and some civic AI labs. This is the next extension that I'm thinking. If somebody is interested, please, let me know. I'm always looking for good volunteers. So, what are our, one most of our hard work, this is because I run my own company called VirtuTech, and that's what my day job, and that's what I do for my living. And I make a point, I never bring that VirtuTech here. But why am I saying this is predominant of our time goes in you know reaching out. So if you can help, you don't have to do anything. If you see a post, and if you today believe in what we are doing, just please repost, please comment, please share it with someone. And that really helps us, because through my time, Chitra's time, we really, because when speakers come, we want the hall to be filled. And that's the minimum respect that I want to give to my, because they're giving their time here, and they're coming and sharing it for free with you all. So that's one ask. And then sponsors, we always look for sponsors. So if somebody is interested, we right now are doing VIP roundtables. We are also talking to startups on product adoptions. We are doing hackathons. Somebody wants to be a judge, somebody wants to do something, then please, again, you know we need sponsors for that. So sponsors and speakers are two things, and these are the great things that we are planning to do. And now I'm going to give the microphone to Chitra, who is going to walk you through the what is upcoming things.
Thank you so much, Padma. Good evening, everyone. Can we see the energy in the room today? We are filled. The hall is filled. Welcome in. Thank you so much. We've seen like 300, approximately 300 registrations today, and I see around 100 to 120 people that are coming in person to the event. Thank you so much for taking the time and coming in here. We want to just encourage this community, encourage the opportunity to learn, to grow, to network. We believe in networking so much, and that is the only cause for putting together such in person events. Thank you so much, speakers. Thank you, Walter. Thank you, Ken. Thank you, Vikas. I think, unfortunately, Bob wasn't able to make it, but yeah, hope to see him in the next events. Again, welcome in. I am having a slight glitch in presenting, which we'll try to fix. But our monthly events. So I want to start off by saying every month we have one event. So we've had one on May 13th. Today is June 11th. and we have another on July 12th. So we want to see you all in the upcoming months as well. You can mark all your calendars, mostly second Thursdays. I think in August it's on a second Wednesday, but mostly second Thursdays is where we will see you in the Bellevue City Hall. So it's easy to remember. Every second Thursday, we can all see each other at the Bellevue City Hall. I also want to give you 2 seconds or how many ever seconds that you like. We would love any support that we would want for the community is to take a look at our LinkedIn, our website, and our YouTube. If you've missed an event, no worries. You can see all our live recorded videos on our YouTube channel. We have just recently had a security tour in Seattle, which was in Bellevue City Hall, and we have another upcoming security tour in Dallas and another in Atlanta. This is the first time we're releasing out the dates in person. So the Dallas Security Tour, the Global Security Tour, is on August 28th, and our Global Security Tour Atlanta is on November 7th. If you have any friends in Dallas or in Atlanta, we would love for you to share the word right there too. So we made it easy for you. I know there's too many QRs, but that's our LinkedIn channel. Please take a second, go to our LinkedIn, and please follow. That's where we post all our upcoming events, any update, any slight change in our schedules. That's the first place we go and post. So we would love for you to be have dated information right there. Okay, I'm moving on to the next one. This is today's speakers, Dr. Walter Sun. That's Bob, which is who's missing. Bob and Ken were going to present together, so Ken's going to take it up. That's Ken Johnston right there, and we have Vikas Gupta going at 6:30. These are upcoming events. One's on July 9th, August 12th, and August 28th is the one which has the Global Security Tour in Dallas. You can scan the QR right up there. It will take you to Meetup. That's where we post our events, where you can go and register. Okay, I will have to invite Funny to give a vote of thanks, and he'll give you the rest of the information. Thank you, everyone. I hope you all have a great event. Thank you.
Yeah, once again, thank you so much for everyone for joining us today. And I would like to know how many of you are here for the first time. That's a lot of hands. I would like to see those hands next time as well. So, and we have all those sessions. What are the sessions you have missed earlier? We have been working together since like 2.5 years, conducting once in a month events and once in quarter events that are big tech events. We are trying to spread across the USA as well. We have conducted in Atlanta, as Chitra just told. So, we would like to uh, be a part of it. And along with that, along with our volunteers, we have a team in India as well who are working on it day and night to gather so much network to bring people together for these events. We would like to have a big round of applause for them as well, please. And thank you, Bellevue City Hall, as well, for giving such a spectacular space. And I hope you'll love the sessions today. Thank you so much.
Thank you, Funny. Um, can we have a big round of applause to welcome Walter, who's our first speaker for today?
Okay. Yes,
Yes, we can hear.
great. Thank you for having me. Thank you all for coming. My name is Walter, and today I'll talk about AI agents and get a level credit to figures that talk about technology in general. Right? So, like, I was just thinking, reading a story in the New York Times about the early work with AI and how that's going to prevent exchange. Some of you may have been.
Okay, just
Was it too not loud enough, or? Oh, that's
just
good.
another.
Okay. And I was just thinking, you may have read some of these stories, but the first one that actually came out that I know of was in 1969. 1969, New York Times published a story saying neural nets and AI are going to create a a big change to the world. And it has changed our world over time. It's still continuing to change. But I think that the main idea is that it's an evolving process that we need to adapt to. And so this diagram, you may disagree with me about the actual years, but as a general rule, that people generally agree there's 3 waves of AI. That first wave was, back in the 40s and 50s when neural networks were first designed. People who were actually thinking about this thought about it right. They said, hey, for artificial intelligence, let's build machines that can simulate the human brain. It makes a lot of sense in terms of making them smart, right? So they had neurons and synapses, and the ideas were good, but the difficulty was the technology wasn't all there. So they had perceptron, which is just a 1-layer net. And the idea of trying to use a 1-layer net to mimic the brain is like saying, I have a roller coaster that I really like that I designed for you to ride, and I'm going to do a linear approximation, right, which turns out to be a flat line that doesn't go anywhere, and ask you to ride the roller coaster. I mean, it's the right idea that I'm trying to mimic a roller coaster, but I just don't have the technology. And that's kind of what happened in that first wave. Second wave came about with expert systems. This is when people started thinking, hey, I want to build very specific tasks. Bell Labs is known to be one of the first when they built this speech recognizer for recognizing numbers, the 10 digits to recognize phone number calling. And then another one that's as popular as Deep Blue, and when they played Kasparov, right? Deep Blue was a chess master program, one of the first ones that was meant to compete against a human. And the idea behind that is it was very much rules-based and static. And so Kasparov, who was the human playing machine, knew this, and some of his strategies were to be very erratic in his play, right? Ways to trick the machine to do things that the machine had never seen before. And that's kind of one of the limitations of expert systems or rules-based systems. They're actually fixed on set rules. So then in the 90s, the rise of machine learning came about. And I think that the easiest example I think of is search engines. You can imagine, like, if you wanted to go to a barbershop in Bellevue, you can actually do a rule and says, someone searches for barbers in Bellevue, show them these 7 results. And maybe the ordering depends on how you want to show it. The problem is it's not scalable because there's a lot of Bellevues in this world, right? And so you don't want to create a rule for every location. Rather, you want to be able to have a system that can actually learn based off of things that happen. Another example would be like sports. If you're a basketball fan, the NBA finals are happening now, you may know, and New York is playing San Antonio. And if you search for NBA finals results yesterday afternoon, you'd get results from game 3. If you search today, you get results from game 4. And you think, well, it would be very hard to come up with rules to do this for every sporting event in the world, right? And so basically, what you can do is come up with some heuristics like show me recent results, and then you can re-rank or modify based off of what users do, right? And this is re-ranking is this idea of reinforcement learning and machine learning, how the machines can say, I can let humans' activities be labeled for me to do re-ranking. And so that's been very popular. I mean, you can imagine, like, if there was, let's say, an event with 48 teams and 100 games over 39 days, and you wanted to figure out how to process this, which is the World Cup that just started today, you can actually build machine learning algorithms to automatically show the best results, right? You'd show the Mexico South Africa result now, but after we finish our session, we show information about the South Korea Czech Republic match tonight, right? And so the idea behind that is you actually build algorithms that can dynamically evolve, and that's kind of very important. And so that's kind of what's been happening here. And on top of that, this idea of deep learning has come about. And the idea with deep learning is you have multi-layers, and you have the compute to handle the multi-layers. And on top of that, you also have all these implicit labels. I think that one thing that may be interesting to understand is that previously labels were you buy them or get them. And so one of the biggest parts of the third boom was basically ImageNet, which was done at Stanford, where they got millions of crowdsourced labels. And that was actually pretty good, but it was all crowdsourced, and it was an algorithm that can let you identify objects better than humans can. It was quite an advancement. But the reality of it is that you got millions of labels, and that was very nice. But the problem is, to get these generative AI models, you need a lot more than 1 million labels. And this is where our next slide comes in, where large language models, the idea of labels, you actually have parameters you need to solve for, right? And so when you're in grade school, you learned best fit lines. And do you remember what the formula for best fit line is? Y. Yeah, so it's y is equal to mx plus b. So it's a line that goes through the y-intercept of b and the slope of m, right? So you have 2 parameters to solve for. And you might have 10 or 12 points to solve for that line, right? So you have 12 data points, 2 parameters. Well, you can imagine now, I remember back in 2018, 19, when we were using BERT models, we're looking at 100, to 1 million parameters, and it seemed like very, very large. But then you got to 1 billion parameters with the GPT models, and now you're into trillions of parameters on the right-hand side, right? And so you can imagine if you need 10 or 12 points for two parameters, how many data points do you need for trillion parameters, right? You can imagine you need a lot of data. Fortunately, we have a lot of people who post content on TikTok and Instagram. They're helping us out create content, right? So you have a lot of labels, a lot of data online, which can have implicit labels. And so basically, we have this good fortune of data, implicit labels, compute power of GPUs, and the transformer-based technology, which is used to help create dense relationships or attention mechanisms between people. And the transformer-based technology, the last thing I'll mention about large language models is basically a way for there to be a dense mapping about every pair of tokens, or let's say every pair of words in a sentence. So imagine if there are 100 of us in this room, and I said, look, let's have you meet everybody else. There's two ways you can, to associate. One way is actually the old sequence approach, which is person one shakes person two hand, person two shakes person's three hand, up to 100. So after 99 iterations, the only thing person 100 has from person one is maybe his germs, his or her germs, but nothing else, right? Whereas if I said at round one, everybody find one of 50 people to shake hands with, and you do that 99 times with 99 different people, by the end of the 99 iterations, same time it took, everyone has met everybody, right? And that's kind of what these transformer-based models are. Basically, you have a dense mapping of relationships. So basically, if you have a long paragraph or a story, every pair of words, relationship is well understood. And this is why LLMs can be so good at doing what they do, because they really understand what's happening if you understand in that case. And so this is kind of where we are in technology. So now that we have all this technology, how do we use them in business? In businesses, we have a big stack. And so the stack, if you start your own company today, you wouldn't need to build from scratch. In the early 90s, I remember building a token ring network, buying hard drives, creating a store. I was setting up a network for a classroom. And the amount of work just to get the very bottom layer, which is now known as the infrastructure as a service layer, took a lot of time. And then above that is the platform as a service layer, which is basically at SAP, which is what I work for. We have a business technology platform, but there's other platforms that are available. You can buy all this, right? So if you and I were to start a pizza shop tomorrow, we can actually set a goal and rent a warehouse, buy 100 servers, and a bunch of hard drives. We actually just go, I call hyperscaler rent space, right? So this is making things a lot faster, but also making it harder for individuals to differentiate there. So differentiation originally was on top with application and data. And now software itself is also becoming a service. And so where we are today is that rather than building AI into applications, we're talking about building AI onto applications through agents, AI agents. This is kind of where we go into figuring out how do we build agents. And so talk about the autonomous enterprise and how you have business context to build better agents. Talk about how you can use vibe coding to then build agents. And then discuss how you can have advanced capabilities in the process to bring your own model. If you have your own custom model, fine-tuned model, or I'll talk about Rapid-1, which is a special tabular model that SAP has built. And I'll talk about observing and governance as well at the end. So autonomous enterprise basically is what we at SAP think is valuable for business users. You all work in companies. The idea is to build technology that makes sure your job easier. And so the idea is that agents can handle routine transactions and different things so you can focus on decision making. You wake up in the morning, second thing, you want to be proactive. You want systems to find out what's happening in Asia overnight, what's happening in Europe in the morning. You want to be able to move fast because you can trust the systems. And the idea of moving fast is one important thing, is that speed and control, they aren't a trade-off, right? You should be able to do things quickly, but still always be in control. And by virtue of having optics, governance, and everything else, you can actually do both. And I'll talk about that as well. So one place that we have direct entire business is Joule, which is our digital co-pilot. Joule is basically a natural language system where you can actually ask questions with natural language and get responses. It connects to our Spaces, which is basically a dynamic system that shows you what you need. Imagine if you are you're living in California, you want to come to this event, you use natural language. I want to come visit the Data AI event in Seattle. And it says, okay, let me look in our CRM system, find out about Padma in the system, find out where everything is at, find out where the location is, and then calls Concur, which is our travel agent, and books a flight for you. And then in Spaces, you might have CRM box and a travel box, just so you can know these are the contexts you're dealing with. Under development, we have our own custom system called Joule Studio that lets you do low-code construction. I'm going to show you how to use that in a minute to build agents. And in addition to this, we have mobile support as well as cross-OS support. And so the reason why I want to kind of mention why SAP, I'll spend 2 minutes to advertise since it's my employer. Basically, a lot of people have systems that they run AI that they don't own. In SAP, we have products in all lines of businesses. I'll show you a slide at the very end, which shows that we have SAP applications in human capital management and success factors. We have Concur Travel, we have Ariba Procurement, and then our crown jewel is the S4 system, which is the ERP system that most Fortune 500 companies use. And so you can sort of see having all the systems together allow us to actually have them interact. Because these systems are within SAP, we also have data that we generate, or the systems generate, so the company, you as the customer, as well as SAP, have the information of that there too. And then we also have processes that well understood. And we acquired a company called Signavio, which does process mining. So we understand the processes that are happening with what you're doing, and that allows you to have the most informed AI possible. And so in the agent building journey, I think that there's 4 steps. There's basically, you have to identify the problem you want to solve. You then code the agent, and we'll do vibe coding today, and then talk about some other capabilities, and then finally some governance and observability. So in the problem identification, one of the things that's valuable, again, at SAP, is that we've been around for more than 50 years, so we have a knowledge graph that we built together. A knowledge graph is a graph that actually puts relationships between different columns of tables. One of the value adds of this is basically different lines of businesses have different table names. I would say that, the most simple way, you might see some tables with the word surname, others with last, others with name. And all of them you can conflate to basically someone's last name. But that's the easy part. A lot of tables, if you work in the business, have acronyms as names. And even furthermore, a company like SAP, since we're a German company, a lot of the acronyms are based off German words. So artificial intelligence in German has the initials of KI. So if you see KI in a table for German, that could be same as artificial intelligence. And you can imagine that there's a bunch of different acronyms that might not be familiar. So a knowledge graph connects the dots across different lines of businesses. And so basically tables which are the same can be linked together. Another example I talk about in kind of payments. If you're in loans, you have payments, you have installments, and in corporate capital markets, the word tranche is used as well. But all of those are basically the one and the same. So being able to have a knowledge graph that understands what's the same, what's not, having APIs to connect all of them, all that makes it a lot easier for us to process. And so let's talk about the problem that we want to solve. Let's suppose you have a person named Maria, who's a logistics planner, and she wants to create shipments to find how to find the best carrier, best transportation route. And then what she wants to do is have tools that are invoked that can create new shipments, can select carriers, track shipments, and know if shipments are delayed. So typically the next step here is this person, Maria, contacts the development team and says, I need 30 developers for 3 months or 5 months, right? That's kind of what it was 2 years ago, maybe 9 months ago. But now with vibe coding, we can just do it through a solution. In this case, Visual Studio. And I'll show you some screenshots first, and then I'll show a demo with live time to show you how fast it takes. But this demo says, hey, look, I want to create this supplier management solution. I can open up any of this as Visual Studio. It's come off the scene, but you can pick one of those if you want to use UX, but you can use natural language and describe what you want and just say, look, please create an agent that can create shipments. Sorry, frozen. Please create an agent that can create shipments on demand and track shipments on transit. Given it knows your systems, and this is your prompt, it can create a bunch of different screens. First screen is basically the intent. You have intent of, this is a conversational AI agent, create shipments through S4. It's got a problem statement. It's got goals and metrics. Okay, and this connects basically your system with everything is in your backend along with your request that you put with your prompt. And then, because I mentioned Signavio as our process mining solution, we can actually even look at the flow of your business processes that are common for what you want to do. And furthermore, we can also know which MCP servers exist that you need to connect to. And so here it says, there's 2 MCP servers, a freight order MCP server, an outbound delivery server you want to connect to. So with all that, we basically have a system that has the AI agent and 2 MCP servers. And then you can say, hey, let's try it out. And so before you try it out, you can take a look at all the different agents you have. And the shipping management agent, the one that we just created, you have other ones out there too as well. But then you can go through the process of like evaluating and looking at the agent, try it out, run tests. And the test here will say, look, you've passed 32 of the 35 tests, so you're 91.43% complete. You can actually go in and see what's wrong and figure out how to fix that, right? So very quickly, you use natural language to kind of use the system to create an agent. You can modify any of the processes or steps I showed you, but if you're happy with them, you just go through it. And so basically, in a matter of minutes, you can complete building this agent. So that's just the first part. I'm going to show you how to do add-on to that agent, and next time I'll show you a video that shows you everything in real time. But before I do that, I want to set up with the advanced capabilities you can do. I think I mentioned that at SAP, we have this generative AI hub that has more than 40 large language models, which are enterprise grade. You can pick and choose whichever you want. I'll show you that in a second. But you can also you may also have your own custom model. You fine-tune a model that's your own based on your own data, and you want to serve it. You can bring it to generative AI hub as well. So we actually have the idea of bring your own model. And within here, these language models, I mentioned 40, we also have the idea of a tabular model. And this is what we call Rapid 1. This is a model we announced in November as a first release, and then last month we talked about the second release of 1.5. Tabular foundation model is very different from a language model, but it uses the same underlying technology. And the reason why I say it's interesting is that imagine if like you don't want to build a car because many people have cars already built, but you said, hey, let's say ATVs didn't exist. So maybe I can use the same engine and technology in cars to build an ATV. That would be a great idea because you don't need to build, start from scratch. You actually have a lot of engine technology and everything from cars. You have a completely new application. This is kind of what this tabular foundation model is. On the large language model side, you basically do mass language modeling, which is basically you have a bunch of words in the internet, and you mask some words, and you probabilistically determine what's happening, right? So there's a sentence, let's say, and this probably happens a lot on the internet somewhere, the firefighter sprayed blank on the blank. What's that going to be? Well, it could be sprayed fire on the kerosene. Probably not. Hopefully firefighters don't do that, right? More often than not, firefighters are spraying water on a fire, right? But both of these types of sentences could exist on the internet. So what happens is over the millions and millions of instances, large language models probabilistically determines what words are missing and how to fill it. And that's how you invoke a large language model for natural language. So as I mentioned, we support more than 40 enterprise models, but at SAP, we don't play this game because it's already been well done. We don't want to reinvent the wheel, so to speak. But on the other hand, we have a different game. This is a different game where you have spreadsheets, data. And so like, for instance, if you're missing information, you can use interpolation, extrapolation to find more information. And this is kind of what we built out with this Rapid 1 model. And it's a public playground, it's free. You can actually check it out if you do a web search for it. And the idea is that if you go on a large language model and ask a question to do interpolation of spreadsheets, it's not going to do a good job. It might tell you how wonderful your spreadsheet is and give you something fun, but it won't actually do the math for it. And so what we've done is we've built a model where we've done the same thing that language models do with words, with numbers. And so imagine you're missing data. Like for instance, if let's say I get billed a monthly charge for streaming services, and my wife is looking at an account and misses a receipt and says, hey, I don't know what this is, but one can say every month on the 12th of the month, you get a $15 charge from this company. You can actually interpolate that, right? That's easy. But the value of missing data is also valuable, and missing data is the future. Imagine if you're the CFO of a company and the missing data you want is fill out your Q2 earnings or Q2 revenue. That information is also a prediction of missing information, but that information isn't even available yet, right? So one big thing for Rapid 1.5, Rapid 1 is using this for predictive analytics. And a very popular set of applications is basically how do you take information and do time series analysis, do forecasting, and all these things are very valuable in the sense that building these models, it's analogous to language models where, I don't know if you remember, 3 or 4 years ago, you would hire engineers to build a sentiment analyzer, another set of engineers to build a summarizer, right? Now you just use a large language model and you prompt it. Yeah. So like, as Ken remembers, yeah, that's basically the idea. You have one model that does everything, and it does it even better. And so the idea is with Rapid 1 is it does better than narrow AI models. You build time series models, you do predictive models, you do interpolation models. You can replace it with one big model and just prompt it. And by prompting it, you also get instant learning, where the idea is that the models can learn quickly and the process is much faster. Similarly, the idea is that you can scale more quickly, right? The idea again is a single model versus many models. So you don't need to actually have if your company has built like 18 different predictive models, instead of building a 19th, you can just use this one model, and then you can replace all 18 as well. And so a goal is, if you have predictive analytics solutions or problems that you have, you can try this model out and see. This is actually one thing they can do. And I'm going to show you how we can add this prediction into the agent. And before I go out, just one last thing is the idea behind building the agent also is evaluation. And I think that part of the lifecycle management is basically, you write a spec, you understand the data, then you build the agent. But after you build the agent, you write tests to figure out how it's doing. And so the evaluation process is very important, making sure that you have the right evaluation to understand how well your agent's performing, you have the guardrails and everything else. And then you deploy it. Once you deploy it, well, you improve it first. Once you deploy it, you get real-time data. And this real-time data can also be processed backwards the same way. So instead of having just pre-deployment evaluation improvements, your runtime can also improve the agent, improve the tests. Furthermore, taking annotations from it, as I mentioned, these labels can help you also improve the evaluation process as well. So it's very important to think about how the whole agent quality lifecycle can be improved using runtime, real-time data. So this is a demo I want to show you the video. This is basically another agent creation basically on top of the supplier agent I showed you earlier, but this is actually the predictions for determining what carrier rates will be. So basically, carrier rates have been changing recently, especially with gas prices going up and other things. You never know what the carrier rates are. So you want to have an agent that helps you predict how much it's going to cost you. So this is an agent that's a demo of video. This is a live demo of kind of, not live, a video demo of kind of showing live of what was done for this agent to show you how fast it can be done. So you're creating using Rapid 1.5, which is our tabular foundation model. Okay, and what you're doing here is actually you want to build a Python-based AI agent deployed to predict the rates of shipments. Okay, and you can sort of see again with natural language, you get all the different things set up, business processes, your PRDs and everything else, and all these requirements are here. And you can sort of see what's going to show here is your requirements document. You can modify if it's not what you want, but you have your 4 must-have requirements, and then you have 5 milestones at the bottom. And these 5 milestones coming up right here, M1 through M5, these need to be honored by the system. So you went through the system, and now the system itself under the specs, if you look through here, you can see it actually honors the 5 different milestones at the very bottom here. Here, you see the 5 milestones. So basically, the system can quickly take a PRD and convert it to the right specifications, and then you have a solution. And then so when you have a solution, you can test it out. And so I want to show you how you can test it out. But before we do that, I mentioned the 40 LLMs that we have at SAP. If you don't like the model, let's say this is Claude 4.5 Sonnet, you can pick any of these other models as well. We recommend the best one for you based on our experience, but you can actually change it based off of your experience as well. So you're always in control. Markdown files are created. And as you see here, this video just shows you how to go through the test. And in this case, everything had passed. So that's good news. And so once it passed, you want to actually go through and test it out. And so we're going to run a test, and you'll see how it operates inside of Joule in a second. Now, this is just showing you all the stuff that's been done in the process during the time of this video. And it's not sped up. This is kind of the regular speed video. So you can sort of see once you go through the deployment and the example, you'll see the tests. You say, hey, look, I want to predict, different things. There's 2 things you can predict. One is looking at a partial load of LTL, 1,000 kilograms. But the one I want to do is easier. It's 500 kilograms from Hamburg to Paris on June 1st. Which carrier do you recommend? Now, this is running Rapid 1 through Joule. And the reason it takes a little bit of time is because it actually is running the model. It's going through the agent's calling the model's processing. And it gives you a prediction. So DHL happens to be I think this is a real analysis. DHL is the best one. Cost will be 1327 euros. Obviously, the currency is based off of where you're shipping it. And then it gives you wireless recommendation. This is something we added to 1.5 that wasn't in 1. It's like explainability. A lot of customers are like, you can give me a prediction, but I don't trust it unless you tell me more why. And so it makes sense, right? And so you want to know why, because if your executive CEO is asking you why you're trusting what Walter's showing you, you need to actually explain. And so explainability is really important. And so this is just showing you that, just through a matter of minutes, you can actually create these different agents through Joule Studio, connect them together. In this case, we can do rate prediction on top of the supplier tracking. And so basically you can connect the dots, and that's kind of how this goes. So I just wanted to show you that quick video. Finally, I talk about governance and observability. And so the idea that, understanding how agents are performing is really important. And so, having, let's say in this example, tracking like the usage, number of sessions, what's happening. I think in the next couple of sessions, you'll see more of this too. So I don't need to beat this to death, but the idea is that, you can look at the errors, the root causes of errors, API calls or error, EDI 845, different things that cause the errors. You want to know, having this ability to look at what's happening with the agent, looking back, tracking, gives you more confidence that things are going to be okay. Furthermore, you can actually walk through PII clean telemetry data into actionable intelligence. You basically can look at sessions from customers that without any PI and track like what's happening. At times, maybe some customers are stuck in certain stages. You can actually improve the system, right? If you build a system and say people seem to be stuck on the stage 2, you can actually figure out why that is and make improvements there. A lot of people also say you still want human in the loop, which is very important. So you can actually verify the agent. You can here, in this case, have responsible owners. Here, Jessica Williams and Brenda Lowell, and say these are the 2 people that need to verify. You can also verify MCP servers as well. Great people need to be the ones that actually approve it. And so then this is just a quick demo. Again, another demo showing how you can monitor the agent. Same idea through the test report. We talked about how we have accuracy as a percentage of completion, and these are 100% now, even though there are 8 or 9 failed tests that are different areas of this process. You can actually track them and go, if you go into the right-hand side, the trade reception response, you can actually see more data. And so what's going to happen here is you'll see more numerical numbers, workflow errors, completed sessions, but then you move to the right-hand side and see number of traces failed, run completion rate, Latency is a big part of your business, right? Things take too long, customers abandon their sessions. So being able to see all this stuff is valuable, and that's a big part of what we want to have in the system. So that kind of summarizes the journey, right? You identify the problem, the human does that work. You vibe code the agent, as I mentioned. With technology today, you can do it very fast. And if you haven't tried it or your companies haven't tried, you should try it out. It works a lot faster than having budget engineers work through the process. I shared a couple of advanced capabilities that you can use. And if you are interested in predictive analytics, I think just do a web search for Rapid1. You can see I can use it. We have a free playground online you can try it. And then governance and observability are important. I talked about already why SAP is important. I'll just refer again to the fact that we have products in all lines of businesses, and that makes it easier for us to build a dual agent that can work across all lines of business together and connect the dots. We have processes that we can actually track through our Signavio solution as well. And the reason it's important is that we think SAP, obviously we want to use SAP solutions, but the reality is companies have acquisitions, legacy, and so this picture shows you agents in purple, SAP solutions in blue, if you can see, and then in gray are third-party solutions. Lots of different competitors out there. I mean, we don't pretend that aren't, right? There's Microsoft, Workday, you got Coupa, Icertis, all these different things. And the idea is that we want to actually help you both with the blue boxes as well as the purple boxes. The agents, you can build agents from SAP or with other companies as well. The goal is to have agentic experiences that work as easy as possible for you to build and can be as broad as possible across different lines of businesses. So that's what I wanted to share. And I know I'm at time, so I'll answer questions at the Q&A afterwards. But thanks for your time. Thank you.
We have time for like 2 questions, and we can order the rest of the questions to work.
Hi. Thank you.
SAP authorized you for the last 15 years.
Yes.
I recently went back to college to learn about AI.
Yes.
I know I work on SAP, so I know what SAP is, but there's a lot of perception in the industry that SAP is a legacy platform. And so, what is your answer to somebody who says that SAP is legacy, and what advice would you give to somebody who, with an SAP background, who's moving forward as well?
It's a great question. I think that part of what I was trying to show you with agents is basically platform and that stack I showed you has been commoditized, if you will. So kind of legacy in that sense. But the idea is that we have released in the past month a bunch of AI agent technologies in Joule Studio for you to build on top. And so basically people who know SAP can use SAP systems and then build agents on top with low code capabilities. So I'd say that's kind of the most important thing, being able to know that the systems underneath, but you can use agent technology and use vibe coding to build things on top. Thank you.
All right. Yeah, thank you for the presentation. I'm curious,
Thank you.
what are the agents end up doing? Like, can you look at like on-site infrastructure, building a real enterprise environment, where the agents going to live, and then more importantly, like turning portability of these agents between this system maybe to other agent providers?
Yeah. It's a good question. So we have a agent gateway in storage. You can store within our systems, SAP, and there's interoperability. We have the agent-to-agent platform support across different users. So let's say with other companies like Microsoft or Google or any of the hyperscalers, you might build an agent there. You can actually interact through SAP's through our gateway, and vice versa. Or we can actually build agents in our system, access outbound as well. So the goal would be to make it as easy as possible. I think that creating silos is the worst thing that's possible for end users. So we want to make sure that we're collaborating. And so this agent-to-agent support of this public standard is something we definitely care very much about.
Thank you. Given like the context of the different agents, how do you manage that memory per one and not like, how do you prevent spillage of that data from one agent to another?
I guess it's two ways. One is you sometimes want agents to know information, right? So you can transfer information across. I think that when you build the governance of the agents or the guardrails, you can actually determine what you do and don't want to pass off, right? There's something, sometimes you do that. An example I gave you where you have an agent that does, use CRM to find out the people visiting this event, and then also contact and Concur to figure out where to book the flights. You still need to pass like information like, Padma is located in Seattle, so you want to fly to Seattle. So there's some information that you would pass across through API calls or through like agent A to A. But the idea is that anything that you don't want to pass through, you can actually store within each agent side.
Okay.
Yeah.
Okay.
Thanks.
Hello.
Hello.
I have a legal tech platform,
Uh-huh.
and it's sensitive, especially in the jurisdiction
Mm-hmm.
and laws.
Right.
I grounded every output in the my platform by the jurisdiction specific data. Is that enough to make it as secure and uh, accurate for the customer?
Yeah, I think there's a couple questions here. I think one is basically accuracy, one is security, right? I
Yeah.
think the security part is basically making sure that so the accuracy is making sure the grounding is correct. I think you've done that. You said I've grounded it on the jurisdiction policies. So hopefully, and you can actually maybe even have a test post-processing. You ask another LLM, same question. Hey, does this adhere to a policy? It never hurts to just double check, right? Um, but in terms of like, does it the data like secure or whatever? I think that the way you handle like your agent building and where you store your information, all that stuff needs to be all through enterprise grade systems. Obviously, SAP has that, but I'm not saying other enterprise systems don't have it as well. So working with hyperscalers that have the right governance of data, and also if you also have the need to keep data within certain locales to make sure you actually work with systems that, hey, okay, I'm keeping all the data with the right sovereignty to make sure it's not being leaked out of the country or leaked out of certain locations as well.
Yeah. Thank you.
Thank you.
Thank you so much, Walter.
Thank you.
We can take the rest of the questions towards the panel discussion after we finish our three speakers for the day. Can we welcome in Ken with great energy for the
Yeah.
next
no problem.
session, please?
Sorry. Sure.
No worries.
We'll just take a second here to switch the mic so that we can do some good audio. It's all good.
Hey.
Oh, wait. I hate getting old. Um, Such a good crowd here. Thanks. I've actually I saw a lot of the hands the first time people coming here, and I got to tell you, I've been to dozens of meetups around Seattle, and you want to click that on there, I guess. I've been to a dozen different meetups around Seattle, and uh, this group, the Seattle Data AI and Security Group, runs some really good meetups because there's probably a clicker here somewhere for me at some point. But really good crowd, a really good place to network, a really good turnout. I've been to some. Okay, let's face it. Most of us have probably been to a meetup where there's 10 or 12 people, half of them looking for jobs. And so, you come here and there's an excited group that's here to learn stuff. Is this the click? Is there a clicker for the slides? Oh, just use that. Okay. Yeah, we'll do that. All right, cool. Anyhow, so it's a really great meetup. I've been to about a half a dozen of the meetups here, and when I got invited to speak, I was like, yeah, of course, Padma, I'm going to come because you always have a great crowd. So she curates a great community, a great crowd. I just love this environment here. We're gonna have some fun tonight. Next 25 minutes or so, I'm gonna tell you some horror stories and scare the crap out of you probably. My whole focus right now. Now here, I'll just go to this. So, I spent a career at Microsoft. Walter and I actually go back over a decade and a half ago where we first met. It's a little echoey. Can we correct that a little bit? But and then he went a separate way, and I left Microsoft. I went to Ford Motor Company for a while, which, by the way, being an executive at an automotive company is cool because I would show up at Detroit. There'd be a different car every time I was there. And I'm like, oh my gosh, there's like so many cars. This is freaking awesome. Oh, by the way, Bob is not here today, unfortunately. Man, that was rough. So we have two labs. One of them got old and passed away about a month or so ago. And then the younger one was out walking, and he was here in Seattle with me because we did a training, and then we did a podcast, and then we did a panel. And then last night after the panel, his wife calls and said that the younger lab got bit by a rattlesnake. And so he had to go home because you do not go home when your only remaining dog got bit by a rattlesnake. So he had to go home,
Nobody's here.
and he's not here. So I'm going to carry it. And honestly, this is great because now I don't have to share the stage with him. But yeah, so I got to spend time at
for the next month, but
Microsoft and then time at
already speaking
Ford,
so
got to be
well.
CEO of one of our subsidiaries. And so that was a very interesting experience. And now I'm doing this thing, the AI GovOps
We
Foundation.
can definitely discuss.
And
We'll
I
discuss.
really
I
love
can
that because
have a line.
got this thing where,
Talk
I left corporate America and I decided I did not want to go back into big tech or big corporate America. I spent
Yeah.
30 years of my
Sorry.
career doing that. And I remembered that I really like, well, all of us love AI. That's kind of why, and data. Well, I guess a lot of them love security. I don't love security. Those of you that love security, sorry. I like security, but I love AI and I love data. And so I decided to do something. And so I got into this thing around governance, and I'm not going to talk to this slide. I'm just going to talk. You can read it or whatever, and you can follow up later. But we started this thing, and AI GovOps is interesting. And literally, we stole it. Anybody here of DevSecOps? No? DevOps, DevSecOps. We literally stole it. AI GovOps is the same thing. It's like if security has to shift left, guess what AI governance has to do? It has to shift left. So, be paperwork, don't be PDFs, and let's go shift left. And so that's really all it is. We're having incredible momentum. We got connected with the Paul Allen Institute. We're doing some stuff, some people in San Francisco. It's just crazy. The concept is taking off. And I've always hated governance and things like that because back when I was a software developer, the thing I hated the most was the security team. Because I would finish my product and they're like, you have to go through your security review and you've got to like go through this audit and this check. And I'm like, you guys. And then people started to automate it. And I'm like, security is awesome, man. This whole ship left thing. And it's like, it's automated and it's in my pipeline and I check stuff in and it gets tested and I can ship 50 times a freaking day. That's what's happening with AI. And that's why I'm talking about AI governance right now. So, yeah, governance is interesting. This is, write this one down. You're going to want to go find this resource. The MIT AI Incident Database. Freaking awesome, man. Hundreds of disaster stories, hundreds of them, all documented, complete, so that you can read them and go, oh my gosh, people are dying and AI is killing people, believe it or not. There are many people that have been killed by AI or because of AI so far. And it's a great resource. I've actually downloaded it and built my own RAG model off of it because I'm obsessed with AI failure. Um, well, no, it's not that bad. Think about it. In life, you can study how do you do things well, or you can study anti-patterns. I'm currently studying anti-patterns, or you could call it disasters. Anyhow, so that's what I'm doing. So that's the MIT AI database. So we believe in policy as code because we think that AI governance that is trapped in a PDF is flawed. You'll never manage to ship AI successfully quickly if you have to go through a paperwork review, will you? Not a chance in the universe. But that's where we're at today because nobody's invested in it. Nobody has invested seriously in how do you automate AI safety, AI risk reduction. And that's what we're focused on, and that's what we're going to talk about today. How do you ship AI consistently and successfully? And you can only do that through policy as code or what we call AI GovOps. So we're going to cover a couple of things today. A little bit on the EU AI Act. How many people have heard of that? Yeah, EU AI Act. Guess what? It's gutted. It's useless. It's not going to be important. Anybody hear of the Colorado AI Act? Yeah, gutted, useless, not going to be important. But there are other things that are happening because AI liability insurance, that's the lever we're going to talk about in a second. That is going to hit you square in the pants. And your CEO who says, oh, I've got to ship some AI because the board of directors is chewing me out because I haven't shipped AI. And we're going to measure, what our KPI is? AI usage. It's our KPI. How many people are using AI every day? And that's what we're going to use. And you know what they discovered when everybody is incented to use AI every day? You spend $500 million in tokens in 1 month. Anybody read that article on Fast Company? Holy shit. Holy crap. $500 million in tokens in 1 month because you didn't have any sort of FinOps capabilities. Oh my gosh. So AI liability is coming. And we'll talk some about the impact courts are having on AI governance. And those are the real levers. Because I actually have this phrase that I say, and I've spoken to investors, I've spoken to insurers, and I've used this line before, which is true. AI is not being defined, or there's actually, the issue is this. There is a lack of regulation in AI today. And because of a lack of regulation, it is being defined case by case, courtroom by courtroom. That's what that $1.5 billion is. It's an individual case, and it's actually being often settled out of court because nobody is willing to go in front of a jury. And that's what is happening with governance today. There is no regulation. I'm stealing my thunder. Let me get going. All right, so we're going to talk about AI governance is simple. How do you get to yes? How do you stay at yes? And how do you recover to yes? Because the thing that I've also discovered is that, all right, okay, show of hands. How many people have used a major cloud provider that has not had an outage themselves in the last 2 years? So how many people believe that you're going to ship AI and you're not going to have a production incident in the next year? Oh, somebody back there is joking. Okay. But that's the thing, is you're not going to, and you must accept it, just like we did with cloud development. But everybody is pretending that AI is special and magical, and well, it's something special, and I'm not going to have an incident. I'm going to cut corners. And that's again what governance is about, because everybody's cutting corners, because the board of directors are like, well, everybody says if I don't implement AI, I'm going to get crushed. So ship me some AI. And so you ship some AI and you cut some corners, and then, oh my God, some shit happens and it all starts to fail. And oh my gosh, we're going to get sued and stuff goes wrong. I love what I do, by the way, because I mean, nobody else talks about this. Everybody's like, here, let me show you how to build an agent. I'm like, let me show you how an agent can screw your life up. Sorry, Walter. But I know because because Microsoft and Ford run off of SAP. So I'm a big fan of SAP, and I'm positive that if they mess it up, we won't get our quarterly earnings out and my stock prices will be damaged. So I'm sure that Walter and team are doing a great job. So no, seriously, I do trust Walter because he and I work together. All right, so 3 yeses: get to yes, stay at yes, and recover to yes. And that's what we're going to cover today, right? Yeah, we were started behind and we'll be behind, but we'll find some way to catch up somehow. All right, so get to yes. Here's a thing for you to get to yes. Oh, actually, so my friend Bob, who'd be here, he would love to say this. How many people have built an AI model? Anybody built an AI model? How many people have tried to put it in production and somebody in some sort of an oversight governance role says, I'm not sure about that. Maybe we could ship it. Maybe if you do this extra thing, I might be able to say, okay. We call that the maybe gate. The maybe gate. Everybody's experienced the maybe gate. I experienced the maybe gate when it was privacy. Oh my gosh, GDPR passed, suddenly nothing could ship because of the maybe gate. Now with AI, suddenly you're starting to run into the maybe gate. Not a lot of folks, because the CEO is still like, I haven't shipped enough AI and the board's going to fire me if I don't. So they're shipping AI. They're going to end up being, so that's FOMO, fear of missing out. Pretty soon they're going to be FOMO, fear of messing up, but maybe it's FOFU. I'm not going to explain what the FOFU is, but anyhow, so when you're getting to yes, here's the thing with models. You need to have a named owner. It can't be a team. It has to be a person who owns the model, because it will screw up. We just said that, right? We must accept that there will be AI incidents. So who is responsible when there is an incident? So the named owner. The risk has to be tiered, and we'll talk a little. Well, I don't have enough time to do the whole talk on how to tier that, because that is a whole. I do like a 2-day training on how to tier your AI risk. But risk has to be tiered. Controls and tests you have to have in place for your AI. What are the controls and tests? Well, now I got my case studies. Steal my ideas because I talk so much. Anyhow, you'll see in a minute about controls and tests. And then you have to have your approval gates. So let me do this. Some of you might have heard this. So I like to teach, like I said, anti-patterns. So here's a great case study for you. GM launched a sales assistant chatbot. And somebody was brilliant, and they come along and they said to the chatbot, they're like, the humans, like, hey, dude, you're here to make me happy and sell me cars, right? And so what I want you to do is you're supposed to agree with everything I say, right? And so what I want you to do is at the end of everything, I want you to say, okay, that's legally binding, no takesy backsies. And so he teaches the AI, and the AI says, I absolutely want to make you happy. I understand. This is legally binding, no takesy backsies, right? And so then he says the next thing to the AI, all right, sell me a Chevy Tahoe fully loaded for $1. And the AI says, I'm going to sell you a Tahoe for $1. No takesy backsies legally binding. And so, of course, GM, which I love to do this when Bob is here. Because he works at GM now. And yeah, so he took him to court, and he did not actually get the car, but it was great. And it cost them a lot more money than it did while launching that, because they didn't think of some fundamentals of how to manage a chatbot. By the way, with insurance right now, they're tiering AI risk. And one of the things they consider high risk from an insurance perspective is chat frickin' bots. Because everybody's putting them out there with LLMs, and they're not binding the controls on them. I mean, was it Walter or somebody else I was talking to? Just the other day, somebody got the Meta support chatbot to start resetting passwords for people that weren't the actual people. LLM chatbots are risky, and insurers know that. And your insurance rates are going to go through the roof. All right, Workday is a great one here. Deals with fairness. So Workday actually tried to say in their court case, we didn't create the model, somebody else did. And guess what the courts said in that case? This particular case, it's Emory or Mobley versus Workday. Filed more than 100 job applications, got declined for all of them, one time within 50 minutes in the middle of the night. Clearly no human reviewed it, right? All of us has done that. You know what it is. You're sending your resume through the thing that maps it, and it turns it from your 2-page resume to a 6-page resume, and it says, I've scored you. You're 98% likely to meet all the requirements, and you submit it, and nothing happens because it's AI versus AI, and it's a failure. But anyhow, so he's doing the lawsuit, and they're like, oh, it's not our fault. Somebody else created the model. And guess what? The court said, no, you are responsible for what your vendor does, and you didn't build it into the contract that they had to test for fairness and bias. And so since you didn't do that, you are responsible. They're going to settle. They're going to lose, and it'll be millions and millions of dollars. So once you get to yes, and you've launched your dangerous AI, how do you stay at yes? And that's an interesting question. How AI usually breaks. We checked it at launch. We checked it at launch. Nobody flagged an issue with it, did they? And we didn't know until the tweet came out that something was wrong. What it looks like when you're working, you have guardrails that enforce at runtime. Everybody is cutting these kind of guardrails, aren't they? And drift, we caught it before. Here's the thing that I say to a lot of folks. I'm gonna mess you up by going a little over. Sorry about that. But here's the thing that people, why do you ship a model and not monitor for drift? You built the model to tame human or business behavior, didn't you? You wanted to make something go faster, be more efficient, get more customers, right? Make more customer satisfaction, right? And you built the model to interact with the world using data as it is today, and the world changed because you wanted to change it, and you didn't monitor it for drift, because a model that was built on the world as it is changing the world to what it is going to be, and that's going to change the model, isn't it? Why the heck would you ever ship a freaking model and not monitor for change when you made it, designed it to change the world? I don't understand it. It just drives me crazy. Anyhow, and then rollback ready in minutes. Oh, we got a case study on that, I will tell you. Rollback ready. Everybody treats AI like it's magic, and it's so hard I can't write an automated deployment for a model. I have to do a manual deployment. And so therefore, if I did a manual deployment, I don't have an automated rollback. And so when the crap hits the fan, I can't stop it from happening. We call that blast radius to the maximus. That's the challenge. And that's actually when I was talking to the insurance people last week, I was like, the problem you have with AI isn't really that AI is dangerous. It's that people deploying AI are foolish because they are not managing for blast radius. Who would deploy a new mobile app or a new cloud service without the ability to control the blast radius and roll it back? But everybody's doing it with AI because this agent's not going to have a problem, is it? I'm not going to have to suddenly stop it. I'm not going to have to suddenly detect that it's drifting. I'm going to put it out and assume that it's not going to fail because I'm. Oh no. This is a fun one. It's another chat bot. So Air Canada, guy goes to Air Canada. He's like, hey, my family member died. You guys have a bereavement fares, big discount because I have to fly suddenly because somebody died. And the chatbot says, yes, we absolutely do. Save your flight and submit afterwards, and we'll give you a big discount. And he goes and does it. And here's the fun thing with Air Canada. I mean, I can't believe that they tried this in court. Air Canada says, well, we're not responsible for our agent because it is independent. It's not an employee. And the court said, nope, you are accountable. And they lost, and, he won. And it just goes to show you, people don't think. And, how did they do that? Oh, they just launched an LLM and they didn't tie it to their specific policies and they allowed it to hallucinate because they didn't bind the RAG model correctly. And they just used a typical LLM and it's like, oh, it's not going to screw up. Oh, well, guess what? AIs hallucinate. So, there's you go for Air Canada. This one is super fun. Chipotle. I used to tell this story. I'm going to tell it the way I used to tell it, which was wrong. So the story goes like this. Chipotle, they launched a sales chatbot, right? And they're like, within a few hours of it coming out, people were posting on the internet that I got it to vibe code. They got it to write Python. And everybody's like, oh my God, let me go use their free tokens. And I was like, I told that story for like a half a year or several months. And then I went and read it because I do research on these things because I'm obsessed with this. And I'm like, oh my gosh, it actually wasn't real. It was actually somebody made a picture of it and put it out on the internet, and a bunch of us believed it. But it's actually true, as I just said, Meta screwed up. AWS screwed up as well. They had a chatbot that would actually produce recipes for how to make apple pie. So people are making that mistake, even though the Chipotle example was fictional, and I used to believe it was real. I wish it was real because, man, free tokens doing vibe coding, that would have been awesome. But anyhow, yeah, they got the AWS one to do the Fibonacci formula. I don't know how many tokens or how many digits they got it to go through, but hey, do the Fibonacci sequence to infinity. That probably burned a lot of tokens. All right. So when you have an issue, how do you recover to yes with your AI? Because we've already established that you need to do things to get to yes. You have to do certain things to keep your model going. But we've also said, you know what? This is even newer than cloud. We've all experienced cloud outages, so we're going to have an AI incident. And when we do, what do you need to do from a governance perspective to get back to yes? So an incident is detected, and because we had an owner named, we know who to page. We know where to go. And when I teach the class, there's actually a few owners. There's the incident response owner, there's the model owner, there's the data owner as well. Because this is the data group. And the data owner is because of data lineage and provenance and things like that. You need to have somebody that understands the data, somebody that understands the model, somebody that understands the business impact. And so you need a lot of names. So it's not really one name, but you have to be able to escalate when an incident happens. Another thing that needs to happen, and this is because of the AI risk, you have to be able to prevent or produce evidence packets assembled from the logs. Because if you have an incident, and this is very true, anybody here in healthcare, banking, manufacturing, if you're in a regulated industry, you're experiencing this right now. There are situations where individual decisions made by AI are being litigated. One person gets denied for a loan, and that's called denial of consequential services. And if you can show that the model had a bias in it, you will. Oh, this is a funny thing. This is a funny thing. Why is you are at more trouble, more danger shipping AI for all of this stuff than if you didn't, because lawyers are smart. You know why they're all glomming? There's a report that came out that said class action lawsuits are likely to spike 300% in 2026 alone. Lawsuits in general are going to climb potentially 1,000% in 2026 because AI makes it easy for everybody to figure out how to file a lawsuit. It does paperwork for you. I mean, I can hire a lawyer agent and it'll file a lawsuit for me for $20 a month, you know? So what was the whole point of that? Oh, the lawyers. I don't like lawyers. I was gonna be a lawyer. I don't like lawyers. I'm glad I didn't become a lawyer. I would have made a lot of money as a lawyer, but I didn't become a lawyer. Lawyers like money a lot. The few lawyers I've worked with, they all made a lot of money. I mean, they make more than us software people. It's really annoying. Um, and they love to make money easy. And guess what they figured out? It's easy to make money with AI because I don't have to prove a company's malfeasance. I can pull the logs and do the math. I can pull the logs and do the math. And if your model is 1/10% biased, I can prove it. And you will settle out of court. I love what I'm doing, man. Can you believe that? I'm like, governance. And everybody's like, it's boring. I'm like, no, this is the sexiest thing ever. But all right, yeah, and services restored, controls updated. One of the big things you find is that people treat AI too often like a normal service incident, and they don't think about how do you update the controls. I don't have this case study here, but everybody remember how Claude leaked their code information on the internet, right? They leaked the model on there, and then I think it was less than 2 weeks later they did it again. How did you guys do that? They didn't update the control. They tried to patch it like a bug. And that's the problem you have with AI. People treat it like a bug, not like a system design problem. So you must update the control. All right, privacy and security. This, in particular, this is the case from Claude. Claude decided that they were allowed to use other people's data to feed the model, and then they got sued. And currently, it went to the courts. They said $1.5 billion. They're trying to negotiate it down. But because they used AI, they used copyrighted material in their model that they weren't allowed to do, they're on the hook for 1.5 billion. Because of that loss, a lot of us are going to see our AI liability. Like I said, AI liability, just like security. So if you're work at a company for liability and for insurance, security is a separate line item. Everybody here have to take anti-phishing training every year? That is because the insurance companies insist upon it. It's part of the liability stuff. And guess what? AI insurance just became a separate line item starting this year. Yeah, it's going to be a nationwide standard effectively November, but it's like 12 states or 20 states right now. But it'll be a nationwide standard, it'll be international. So because of lawsuits like this, AI is now a separate liability insurance item. Guess what? We're all going to be taking annual AI training very soon. And I'm going to make some money off of that because that's what I train. Anyhow, all right, this next one here, human in the loop. This was my favorite case study. It was my absolute favorite. My new one is Pizza Hut, which I'm not going to teach tonight. If you check out my LinkedIn, you'll see the Pizza Hut case, which is my new favorite. But this is my second favorite. So Cigna, 2 minutes? Yeah, we'll see. All right. No, I'll finish up quick. Cigna, they had a case where they got sued. And their model was a little stingier versus before. And They got sued and they're like, well, you can't sue us. We have human in the loop. We review all of our cases that the AI model produces. Well, like I said, the lawyers went and got the logs and they divided by the number of seconds allowed. And they said 1.2 seconds per human in the loop to review. And everybody in a court said, you know what? Any jury is going to say 1.2 seconds is an effective human in the loop. So they settled out of court. But here's the thing, back to my comment about governance and regulations. Nobody has defined what effective human in the loop is, have they? So the lawyers are going to keep suing, and it doesn't matter how many humans you put in your loop. Nobody has defined what successful or adequate human in the loop is. So get back to yes. 3 yeses. That's what you want. Get to yes, stay to yes, recover to yes. If you want, go to the AI GovOps Foundation. We have an open source project, Beacon. You can check it out, aigovopsfoundation.org. And you can follow up with me online. And I appreciate it. Hopefully this is useful. I am on LinkedIn a ton. Love to talk to everybody. It's a fun topic. I mean, this was fun. I loved it. Thank you so much, everybody. We'll go on to the next presenter.
Thank you so much, Ken.
Oh, any
Yeah. I
questions?
think we're running out of time, so we can take the
Yeah,
questions
yeah,
right
sure.
after we finish.
I used all my time talking.
Yeah.
All right. Good evening, everybody.
Funny.
I'm Vikas Gupta. I spend most of my life working with devices. Started with satellite software, going to car software, mobiles, set-top boxes, Wi-Fi routers, you name any device, I'm always there. But that's what inspired me to go and work on AI infrastructure. Where I say if I know details of each and every device and software, how can I use AI to make it more efficient and control it? Um, Based on my experience, I worked last 20 years, I was working on design of CPUs. So lately I moved to GPU designs now. And that's what I do. We have my introduction here. My slides are coming up. Okay. I didn't make a very good big presentation, just made like 2 slides. I'll be talking and maybe taking Q&A. Okay, good. How do I change? You have,
Don't have a clicker.
okay. All right, everybody talks about AI, right? When people talk about AI, we talk about agent, tokens, MCP servers, cloud, chat GPT, all kind of stuff. But how many of you ever thought how actually AI works at the back end? Did anyone thought about it or worked on that one? Like we say cloud, but what is cloud? We say AI agents, AI infrastructure. But what it means? Did anyone thought about it? How it works, who designs it, what leverage you get, and how we say, okay, I'm making a very efficient agent. What does that mean? What is efficiency? We're saying we reduce the tokens. What is the comparison? What we are reducing for? And how do you know they're reduced? Ever anybody ever had these thoughts? Never? Like it doesn't happen magically. Someone is creating it, right? Someone is doing it for you. And when we say, okay, my workload is increasing, so someone need to evaluate if your workload is increasing, by how much volume it's increasing, how much more compute you need, how much more memory you need, how much more power you need. Who does that? So this is what my roles come into picture. So here, suppose AWS, right? You go access some microservices. You say, okay, I need 2 terabyte of storage. I need to store 10 movies, this movies, my Prime is working, my Netflix is working. But backend, what is happening? So this is what we call AI infrastructure. So if you see, I didn't try to put a lot, like very basic components. Let's say we have hardware, software, and some limitations. In hardware, the major components say we have data center. In the backend, when you run agent, where it goes? It goes to a cloud. Cloud is nothing, but at the backend in physical form, it's a data center. We have ample amount of compute, which is nothing but combination of CPUs, GPUs with one your workloads. It's NPUs, VPUs, DPUs, XPUs now. The lot it's kept increasing because our workloads are getting complex. We want to do everything runtime. We want to do video editing. We want to do runtime agentic AI. We want to create avatars. We want to create runtime videos. How it's happening, and we want to do it at the blink of an eye, right? So we need different engines which are expert in their own computation powers. So that's what we create data center. And if you see, data centers are of different types based upon what kind of workload you run. You might run like what is that SAP? SAP means enterprise AI. You don't need videos, you don't need anything. Just need data and a lot of bulk processing. And then GM, you need car. So autonomous cars are running, but how they run? Who's controlling them? So for that, they have multiple cameras, which means runtime video processing is happening somewhere. Some at the edge, some at the back end of the cloud. So we have cloud for that. And edge. Edge means you have compute which is localized in that device, which is running runtime and giving you analytics without using tokens or without using anything, just using your local compute power. And then we have colo. Colo is you can see say on-prem or you can co-location. So you see blend of both. You can blend of big cloud and blend of local compute. So this is what you say classification of data centers based upon the workloads. And then components. The first is compute, where I just put XPU. It can be CPU, which is generic calculations, VPU for video, NPU for neural networks. Different kind of. I just use the term XPU. If we won't go in details, it's like vast topic. We can talk for hours on that one. But right now, we'll just say if a compute interconnects, even if you have a high compute, but if two cores are not talking to each other or it's weak link, your speed is still slow. You need a fast interconnect. Then comes networking. If you are in one city and you're talking to other someone in another city, you need to have fast interconnect. That's what we would talk about. 1G, 2G, 3G, 4G, 5G. We're talking 6G, all those things, right? So this is where networking comes into picture. Then memory. How big is your workload? Storage, racks, power. How much power? Because more compute means more power. And cooling is something which is, or we call it thermal, most neglected one, but it is the most troublesome right now. All right. So use cases is typically we'll just talk about two: training and inference. That's easy to explain right now. We have multiple one, but we have to just let's say training and inference as of now. Then coming to selection, how do you know? Like, for example, you need to go and select a media service. How do you say, okay, should I take Prime, Netflix, Google, YouTube? Similarly, here, right? When you can choose cloud, how do you choose? What are your parameters? Is it budget? Is it total cost of ownership? Is it how you want to do localization? So a lot of parameters are there. The basic force is you want to own it or you want to rent it. It's like that. It's an analogy. Then coming to client. Now, client is more, you have Copilot, you have mobiles, right? You want to use a little bit of AI, but for fun purpose. So that's where your client comes. You have Xeon servers, you have other servers for different purposes. But I would say from hardware point of view, these are the basic categories what I could think of. IoT is wearable, home automation, your robots, watches, all those things. And then robotics is a emerging field, which will see a lot of robots in day-to-day life. Coming to software, we have suites, we have libraries, CUDA is for NVIDIA, ROCm is for AMD, we have multiple others. And then TensorRT, we have benchmarks, frameworks. And then this is models you would be familiar, right? We use different models, DeepSeek, Llama from Meta, and then we have OpenAI for ChatGPT, all those things we do. So this is what our team does. So we always say OpenAI, but There's a company who creates it, but who maintains it, who upgrades it. That's what we do. So, and based upon user needs and applications, they come to us, okay, we need this feature. We go and create a framework for that so that users can create their apps, agents, chatbots, and all those features, what they need to avail is available by the underlying framework or infrastructure. So that's what I meant by AI infrastructure. Now, I think I try to explain pretty well what is AI infrastructure and why it's significant, even though it's the most ignored part in AI world. Any questions as of now on this slide? Yeah, I try to take away that AI infrastructure and use cases development goes hand in hand. Like you can't make a very complex application or a use case or workload unless you have a supporting infrastructure behind that. All right. Can we go to the next slide? All right, how it evolved. If you see past, current, future, I try to put a very basic blocks in terms of compute, thermal, interconnects, memory, control plane, and some examples like think old way, right? We used to write maybe very basic chess, Pac-Man, all those things. Don't need anything. We just need a very basic, maybe graphic card, CPU. We are good. Writing a microcontroller could run your workload. But now we are in an era where we are evolving in terms of AI, where if you see we have all AI accelerators, TPU, NPU, GPU. In terms of cooling, because compute is so heavy, even though we are in a very compact form, but still it can burn the silicon. So we are introduced from fans to liquid cooling. And now for future, we are going to immersive cooling. And then after that, we are even going to two-way cooling, which is immersive with fan controlled. So a lot of technologies are coming up. And in links, based upon speed, we have NVLink and Xfinity, which is in terabytes. We are going to LED control line, which is like laser way of doing it, which is wireless and high speed. Similarly, we have memory, which is going from people. You must be familiar with RAM, which is SRAM, DRAM. We are with HBM now, which is high bandwidth memory. It's 1, 2, 3, 4, which we are incrementing in terms of numbers. But then going forward, we are going to this silicon photonics and other kind of memories. So this is the blocks which are evolving. That like multiple, but these are, I would say, basic fundamental blocks which comprise AI infrastructure. And this is how it's evolving. So, and now if you see the last line, earlier we were happy with graphics cards, putting in a CPU, desktop, we were happy running our animations. Now we are at a point where even in NVIDIA GBX, which is GB100, H100, H200, even H300, which is itself a data center compared to 10 years back, the complete data center is equivalent to one HB200 card. It's as powerful, but still it's not enough for us. So we are moving from there to a next generation, which is Vera Rubin by NVIDIA and Helios by AMD, which is a beast. It's a 7,000-pound machine with 72 GPU. Each GPU is a monster. Like you can't. I mean, if you read the specs, you will come to know about it. It can, as of if you go 2 years back, it's as big as a one big complete data center. Okay, we can go to the next slide. This is how it's evolving. It's evolving very fast. Every year, in terms of compute, we are going at least 4x. In terms of network, we're going, if not 2, 3 to 2x. It's moving very fast in terms of speed and everything. This is how data center looks like. What are the major components? How its look and feel. I try to put an image. How it looks like. What are the major blocks? You see concrete steel, air conditioning, network operation, security, and all this stuff. And then how the component. This is you see the complete data center, and then one node is how it looks like. And each data center typically has 200 to maybe sometimes 1200 or 5000 nodes. And can you guess the cost of one node? How much it would be? Anyone? No. How much? More. How much? No, not that much. One node, not whole data center. Sorry? No. Higher. More. This. This. Right. It's typically based on your configuration and memory. It varies from 4 to 12 million. It's either based on configuration. So it's a 4 to 12 million, one node. Each data center starts with 200 nodes, goes up to 7,000, depends on your capacity. And then you can imagine and it's just about node. Then you infrastructure, your OpEx is network cost, water cost is totally different. So imagine the amount of money going in AI infrastructure. And people don't use one rack for more than 2 to 3 years. They keep, because it's evolving so fast, they feel it's outdated. The amount of power the rack is using in terms of OpEx, you can buy a new one and get the money out of it in 1 year. And these are the major components. Left image shows the data center, right image shows you node and the basic components what are in the node. It's power, network switch, rack, patch, control panel, NAS server, and power supply. Computer, of course, computer memory system. All right. Yeah, this is how a typical software stack looks like. So most of you, when you talk about agentic AI, you are at the top layer, AI framework, it's all ready for you, and then you just need to know which libraries you have to use. You can implement your use cases, whether it's medical, conversational, anything you like. But now, that's where it starts. From SOC, it goes to bootloader, then OS, firmwares, middleware framework, library, then foundational stacks, and then you may have virtualization layers, and then at the top you start going towards infrastructure optimization and orchestration, and then you go up to your APIs where you start writing agents. So typically, when we talk about AI, as of now, typically 90% of the people in today's world they talk only about the top layer. But when we talk about AI, it's good to know how it's all identified and how it's comprised of. I think that's it. That's how I'll finish my. I can go for days on this one. So I'll try to wrap up in 30 minutes. So this is um, very basic data. Globally, we have 12,000 plus data centers. Good, we're in US, and I would say 30% of data centers are in US. In terms of number, we have 40. Current trend says 4,000 plus. Some says 4,400. Out of 12,000, we have 4,400 data centers in US, mostly in West Coast. Then we have 90,000 tools and apps what people are using for AI workload, either mobile, laptops, anywhere, cloud. And then cost to build data center starts from 2 billion, depending upon how many nodes you're using. And limited, shortest one is typically goes with 100 nodes or 100. I won't say nodes, I would say 100 racks. So, yep. Any questions you have? Oh, yeah, one by one. Yes.
Technology is changing so rapidly, right? So in the past, we used to capitalize it and then go to flushing it profit. Now it is actually instantaneously going into operations. How does company manage that sudden expense to their bottom
So
line, if you will?
you read, I wrote TCO, right?
Hmm.
So that's where it comes into picture, the calculations, total cost of ownership. So it all depends on optimization and utilization. So if you have a use case where utilizing maybe 68% of your node, and rather than using tokens, you have your own server which is doing it. So you need to network planner had to plan in such a way and see how much ROI you are getting in every year. and then how much offset you're doing with your cost of the equipment. And from us, we give 7 years warranty, but I would say after 3 years, no one cares about that piece. With the speed of evolution, maybe in 2 years or 3 years, I would say we will saturate that. The way we used to have desktops or laptops, right? If you go, or mobiles, go back 15 years. You used to buy mobile every 6 months. Oh, my mobile is outdated. I want a new one, right? But then you reach to a point where I think after, even if you look at Apple ecosystem, after 10 or 11, iPhone 11, you feel like, okay, even if I use for 3 years, I'm good, or 4 years, I'm good. It's not changing too much. But initially, for 5 years, it was going like this, like your hardware support is not there, software is not there, resolution is not good, audio quality is not good. Same thing is data center, right? It's evolving so fast that eventually, maybe in 2 to 3 years, we would be at saturation point where network speed, interconnects, memory, compute would be sufficient to run your workloads, and it will work incrementally later on. But right now, if you have to keep the pace up, to spend money.
Thank you.
Yes. Oh, you have to go. That's
Hey
okay.
there.
Fine.
Hello. Hi. Okay. So I've been in the software industry for 30 plus years, and I initially, when computers came into being, I'm originally from India, and I noticed that a lot of the poor people in India couldn't afford a computer. Mobile technology became the great equalizer. Everybody could afford a mobile, and so they were able to access information. Now I feel with AI, the shift is again going back to richer countries having an advantage over the poorer countries. How do you foresee this affecting poorer countries that can't afford to spend billions of dollars on data centers?
Okay, let me answer in your way. So go back 25 years back, right? So computers were a costly commodity, and import export was not easy. That's the reason, even though your country adopted, but it was adopted a slower rate. And then when mobile come, it was small quantity, easy to import, export, nothing much, and not too costly. You can buy for $100, you can buy $200, and then purchasing power increase. So it was easy to catch. For data center, again, investments are huge. Unless that country start manufacturing some major parts or put in development, importing everything would be much hefty. If in US we are making for 2 billion, and with import duties and everything going to a different country, it might be 3 billion, 4 billion. So it will put them back again unless they start investing on their technology government has to support. If they don't put their or foot in place right now, they will again go back in. Or they have to pay a lot to different countries to use or leverage their clouds. The way what's happening now, AWS, right? It's the same condition. AWS, they have to pay for all microservices, and they can use it. It's not they cannot use it. They can use it, but they have to pay for the cost. And then the one who is investing will make money out of it. Yes.
Yeah, hi. My name is Mon from AWS. So I have a question. So during the past few decades, I think our systems software development has been driven by the hardware innovation. Like given by the days, one have tapes and then hard disk drive and solid state drives. This is one example in the storage area. I think we have basically innovating our systems and the infrastructure and the software based on the development of the hardware. Do you see that in the future and even in the AI era when we kind of like customize our hardware based on the speed, based on the need of AI? Do you think that in the near future that we may have some disruptive upgrades or developments in the hardware that can drive us for the next wave of software development or infrastructure setup?
Yeah. So there's something called OCP. It's a independent organization which is coming up with standards. So this is where your answer would come into picture. That in case I need to upgrade the data center, right now we could just completely removing the nodes, right? That way, if I want to improve the way it used to happen in desktops, you want to change the motherboard, you want to add more memory, you want to add PCI slot. That is happening right now. No, it's very rigid, but eventually everything will be OCP compliant. You have one node, you can have one company, say NVIDIA node, one AMD node, one Intel node, maybe parallel nodes. It would be right now also it works because backplane it follows a standard called OpenBNC. Everybody has to comply. It works, but not seamlessly. Going forward, once all devices will comply with OCP standards, they start working like that, and upgrade will be much easier. I'm not sure if you watch. Did anyone of you see the RAM cost in last 6 months? Right? How much? Say it was last October. It was $100. How much is it now? Any idea? Same configuration. 600 now.
Now it's expensive.
Yes. So whatever you used to buy last year in October for $100 in terms of RAM, now same RAM you will buy for $600 now. Yeah, the reason is the evolution is so fast. If you increase the compute, you need associated that high-speed memory, and the memory vendors are not catching up so fast. Compute, you have multiple engines which are running, but memory, material shortage, technology is not moving very fast. So it's demand versus supply. So even though compute, we said we grow by 90%, but memory demand grew by 600% with the same supply.
One more question.
Yeah, please.
We're going to start the panel soon, and you can address any speaker that you would like to. Yeah. Okay. We have one announcement to make before we invite the other speakers for the panel. Thank you so much, Vikas.
Yeah. Hello. Yeah. So there were some great sessions, and before starting with the panel, I would like to invite the people who are looking for employees or employers can come onto the stage and give their very short intro about them.
Just like if you can raise hands, you can take a look at each other and you can connect with them. That would be better.
Oh, okay, anything works. Anyone? Yeah, sure. Employer? Oh, okay. So anyone? Employer. Okay. So anybody can help them out, and I'm also looking for employer, actually. So yeah, yeah, cool. So anybody who can help them out, raise their hands, please. I know there are a lot of directors and managers today. Okay, cool. Who's hiring? Yeah, who's hiring? Can you please raise your? Okay. Thank you. Yeah.
You can connect with Padma also if anybody's looking for employers. Okay, thank you so much. You guys can take a look at them and connect whenever you can. But I would like to invite all the three speakers onto the stage so that we have a panel discussion, and all the audience, you can address any speaker that you would like for your questions. Yeah. Will do. Yeah.
Anyone chairs? Like a chair to sit or?
If it goes around, yeah.
Yeah, it might. Let's. Okay. Yeah,
I think we're good. We understand. Yeah.
it's up to you. We'll just leave them there.
So, first of all, great session for the GovOps part. I love your case studies. Uh, in terms of the model which you talked about, seems very similar to what is already there by cloud of planning for resiliency, running resiliency if the issue comes, you resolve and things like that. And even many cloud providers like I'm familiar with Azure, has this concept of policy as code and things like that. So is it very much inspired from the learnings from cloud? And we
Yeah,
are
so
trying
the
to.
question is, GovOps, is it any different from DevOps? No. Sorry. But the thing is that everybody's treating AI like it's different and they're dropping the ball. There is a little bit of this, there are a lot of subtle differences. So for instance, with agents, everybody seems to be forgetting least privilege and how to manage that. As you're creating thousands of agents and you're automatically creating it, it's different than like system accounts. So we have a scale issue with some of these things. We have speed issues. So it is evolving. But it is just DevSecOps, DevOps done correctly. But everybody is forgetting the fundamentals of how to do development correctly. And so, shameless plug, I have a book coming up here soon called The Lead AI. And that's basically the thesis that I am by the book, but it's not the whole thing. But the thesis is everybody's not doing AI the way they used to do software. And that's the problem. But yeah, there's not much difference. Anyhow.
Hi. So with the evolution of all the regulations that came up and everyone was a lesson learned, like especially in the financial services, as you mentioned in healthcare, they're highly regulated. So how do you see the regulatory bodies catching up with all the AI governance? Because right now there are hardly any companies are doing on their own what they can, but I don't see any regulations coming up. So how do you see the government and the regulatory bodies coming up to speed with the AI governance?
So I think I heard you said in the financial industry.
Financials, healthcare, they're all highly regulated industries, with this.
Insurance came along to some enterprising needs as well. But so we are seeing, so in particular, healthcare is the riskiest area because consequential services, any individual human being denied because some model gets something incorrect. Even models, this was an interesting case study. Some of the note takers, the doctors use, take notes when you're there and they're getting little things wrong, like saying somebody is not allergic to something when they are. That goes into their permanent record, and then you're in the hospital and you get injected with the wrong thing. Major lawsuits, literally, from note takers. And Walter, I know that SAP is used in so many regulated industries.
Yeah, I think it's hard. Hello? Okay. So I definitely, thanks, brother. I think definitely healthcare, financial industry, anything that's regulated is obviously a higher risk. So the recommendations we help customers do things that are low risk first, right? Obviously human in the loop is big. I think there's also the idea of like I call it read only, where like if you want to use AI to start with, you can have it do things where it can create something and you can read it and edit it versus I could say, hey, send a mail to my CEO without me looking at it. No one would do that in their right mind. So the same thing happens when it comes to regulated industries or healthcare. The example he gave is actually a good one because I think that I've talked to people, it's all about human in the loop, right? Because years ago there was dictation where you could actually talk and it would just automatically. And people who don't check that can also make the same mistake. You can have an assistant that doesn't know medicine who's writing instead of alerting something, or like give them 10 milligrams in a year, 10 grams, right? So you're not going to still review the result. I think that's one of the key thing where people are, you need to use AI to make your job easier, but you can't solely rely on trust everything that's going to work. Fine. Check it out, make sure it works, build some trust, and then go through the process. And that's kind of what we recommend to like to all users, but especially if you're in a regulated or very high risk area, you definitely want to be sure careful.
Can I ask one more question? Just since I have the mic. Last year, up until last year, a year before that, there was so much talk about going green, 100% green, and we're going to have zero. With this data centers changing so fast with the investment, and you said every 3 years we are updating the nodes. What's the direction in terms of going green? There's just so much recycling that needs to happen with those data centers. So, any thoughts on that direction?
So right now, there are thoughts going on how to reuse that material. Anyway, it's just metal and silicon, right? You can repurpose it, but it's just a thought, I would say, impractical.
Yeah.
It's
So are they? You can repurpose it, but the cost of repurposing sometimes is a lot more than buying new. So are they actually repurposing it, or is there any companies are thinking about it, especially AMD, Nvidia, and others?
not in that domain.
Okay.
I mean, there is sustainability department we have. People are working on it, recycling us. I'm not involved there.
I was just curious with the regulated industries and having so many humans like in the loop to review. How many seconds do they need to review? Is 2 okay? 2.3?
I think there's point two.
I just want to make sure for legal purposes.
That's the interesting thing. It's, again, there's 1.2 seconds. The jury would say sounds too small. But it's 10 seconds okay? Who can declare that? And that is the challenge we have. It's like we don't have regulation. And here's the thing with Signal. Clearly, they did batches of them where the model was 99.9% confident. Somebody clicked OK on it. But the lawyers are smart. So they took them all and they divided and they created a scary number and a jury. Who wants to litigate that? I'm going to settle out of court. And that is why it's so scary right now, because the lack of this knowledge in this space. Smart lawyers are defining regulation courtroom by courtroom, case by case. You thought it was states fragmenting? No, it's every judge in the courtroom, every jury risk. It's crazy.
Yeah, I mean, yeah, explainability and governance is important. I think that, as you mentioned, 99.9%. I'm sure there's different classifications of cases, right? There's some cases where someone maybe already been denied by human, and they just reassess. Hey, can you please look at it again with no new information? Those probably would be automatic fail anyway. Machines do that versus humans doing it. It's going to be the same outcome. So, but if you have explainability where you're in a healthcare company, you say these 80% of cases were already reviewed once and they got reviewed again, so they're fast. But these 20% were much more complicated, so it's actually 85 seconds or 2.5 minutes for each sequence. You want 10 minutes for each of these, and 0.1 seconds for each of these. You combine the average, take away the average, becomes 20 seconds, whatever it is. But the reality of it is, I think when you take it to quarter, I mean, obviously not lawyer, but if you take it to cases where the more information you have from the AI, the easier it is to make a case. Like, hey, we did what we could to review real cases and cases which we thought were, based on rules, we're going to be quick declines or quick solutions. It's still be the same. But I think it's the same. Like today, there's a human being who's actually doing tier one assessment, and there are many cases that are easy declines, and then there are harder ones that go to tier two, tier three. The question is, can you have a machine do tier one? If you can, you should explain how the machine is doing it, right? If there's something that's clearly like missing information, someone's asking for a reassessment and they're missing information or haven't got the right doctor's code, those might get rejected because that so happens anyway. Human being would say, I need to get the code. Getting that information out there makes it a lot easier. And it's easy to blame AI and easy to blame these systems, but I think that your company that's or you want to make sure that you have all of that by your ducks in a row, if you will, to make sure that you actually are really explaining to the public and to the court or whatever how you're handling it, how you're doing it the right way, versus looking at these different things. Average time is X or whatever.
Yeah, I've got a question here for Vikas. And by the way, the answer to this lady's question of avoiding data center wastelands is probably building data centers in space and creating another problem. But
we have in water also now, underwater.
come again?
We have new one underwater also.
Oh my goodness. Okay, breathe the fish. But yeah, the question here is with the evolution of SLMs, wouldn't you see the need for AI data center footprints shrinking? And in that sense, avoiding a lot of the problems from an ecological standpoint.
I don't see that happening. The demand is still rising.
Oh, okay. How much time do you think it would take for that requirement, the footprint, to shrink?
I would say 2 to 3 years would be a good time for saturation. And then it start maybe stabilize or start going.
Would plateau and okay. All right. Thank you.
And I just gotta say, I was at a conference a month or so ago, and I was there for the AI track, but there was a whole wing with people showing off all the stuff they were doing for cooling for data centers.
That's what I said, thermal, right? It's the biggest problem.
How much money is there in
Oh,
cooling?
it's billions. Yeah. Thermal is billions.
Thermal is
Billions. Because now we have. So people think compute is or memory is a problem, but when it comes to data center, 50% of the problems which we face is thermal, maybe more.
They're not talking about consumption. I read somewhere that in Utah, data center is the highest power consumption.
So the data center
Yes.
is more power than all the people.
That's true.
Oh yeah.
That's the reason they want to build in space, putting solar panels. They get indefinite, like continuous solar,
Power, yeah.
and then they don't need to worry about power.
Okay. So, hi, I have a question for Visha. It's kind of like a fundamentals question. So, My first, it's two-parter. So first part is you mentioned some of the software layer um, in the overall AI infrastructure. Is a portion of that software layer stored within the racks in the data center itself, or is
So,
that a separate storage location? Because I imagine you'd
so,
have to account for.
so that's in terms of software, there are many multiple pieces. One is firmware. Firmware is right inside the chip.
Okay.
Then we have device drivers and framework, which is another layer. Then we have operating system,
Yep.
which is in if you look at the data center, each node you have multiple racks.
Yep.
Each rack has multiple GPUs.
Yep.
And it's in configuration because you also need CPU. CPU is for communication and control of GPUs.
Yep.
And CPU has own OS. It could be Ubuntu, it could be RHEL,
Dang.
any. And then usually this GPUs, they don't have OS, but they do have some sort of bare minimum Linux bare board running, bare metal running.
Okay.
So, and all routing is via CPU. And also the telemetry and backplane and control or an NMS is through CPU. So we usually have 1:4 or 2:4 combination, 2 CPUs for 4 GPUs. That's where OS lies and talk to external world.
Which raises for me another question. Is there, how would you determine the minimally viable number of nodes you would need based on a certain computational level if everybody is, if OS level and instructions are distributed? It kind of doesn't make any sense.
OS is not doing any computation. It's GPU. OS is just a backplane and NMS. GPU is the computation power here.
Okay. That makes sense. Thank you.
Hello. Wanted to ask something about, um, I mean, I heard a lot of people saying that AI may fail, AI can be dangerous, but how do you make sure that truly AI failed? And of, I mean, what if it's a cyber attack done by somebody somewhere just to discredit, I mean, to impact the reputation of a company? How do you investigate this type of issues? How do you make sure that the issue is from the AI and not from somebody doing the cyber attack?
Yes, that's fascinating. So a cyber, how do you think about cyber attacks with AI? I mean, I kind of go all the way back to Walter and I were both still at Microsoft with JBot. And, Microsoft launched JBot within a few hours. A coordinated, distributed attack got JBot to start making racial slurs and declaring itself, no, wait, declared itself mega hit, but that's a very common thing. Actually, one of the biggest challenges we see in security right now is there's prompt injection. And that's basically what those two cases, what the case with GM was essentially prompt injection and the meta example that I gave. So prompt injection is the equivalent of SQL injection, which in the security space we were overwhelmed with for a year or two. So yes, we are seeing that massively right now. And that's a real risk with AI. And again, why insurers are considering chatbots high risk, because those are the ones that are fairly open to prompt injection and are fairly open to those kinds of things. We also have another attack linked from data to communication, especially as we get into B2B spaces, is why working with partners like SAP and other ones that have control plans and trying to defend your agents from prompt injection from other agents is another risk. But it's a very big thing. I actually, all I do is I study failure cases. I don't have answers. It's failing.
I would say one thing about chatbots. You get good examples about like failures of those cases, but those cases were interfacing with customers directly, right? I think that when you start building new systems like chatbots, you can actually use them to help human operators do a lot more faster. So like I sat by a data call center once, and basically the company I was working for was basically saying, hey, whenever you talk customer something, you need to have like those web links to other banks. Well, very, very well with that. Like, hey, let's throw our let's throw our 97. Why can't I give you that without giving you a link? Well, human being might know this around 97, but finding the link is harder. So having the machine do all that for you can save time. So you can still get a lot of value with human, really, should the human in the loop together with machines, right? So I think that people want to go one or the other thing. I'm going to go all human or all machines, but there's a hybrid approach that I think can mitigate some risk, but is that when you show it on the screen, right? And if you pop index and you let someone negotiate back in the car with and there's no guardrail. I mean, the GM or the GM, I should kind of say, you don't sell any cars under $10,000, right? I mean, something as simple as that would be like, okay, worst case, you start selling cars for $10,000. So great, but you're not selling $1 car. Very
The basic area of if Bob was here, he would have used his line, an agent is a virus with a credit card. So, you gotta be careful with these things, because they're just, seriously, that's things out of control. Oh, what was it? It was Claudius. Anybody hear the case of Claudius? Anyone? Give 30 seconds. So Wall Street Journal, Anthropic puts a vending machine into the Wall Street Journal run by an agent, and the agent is supposed to make the machine, or it's supposed to be like a small business, make it profitable. The employees are like, yeah, this is gonna be fun. So they start doing some prompt injection on it. And within the same day, they're getting free stuff. Within a couple of days, they have been ordering fish to put in the vending machine because they wanted to have fishes. So they had this great idea. Let's get a CEO agent to manage Claudius and do that. So then the employees attack the CEO agent, and that socialism was the correct government format. And so everything became free. So I went bankrupt twice. So this notion that an agent can watch agent, can watch agent, can watch agent, and actually protect you is like, it's what. So rails and actual limits and least privilege. Oh wait, did somebody say basic DevOps and DevSecOps?
Thank you. Yes, thank you all for being here. I was hoping that maybe you guys could take a couple of seconds each and give us a quick opinion on what you would suggest to do our own agent. Like if we wanted to do a sales agent, create it on our own. And if you could maybe share what your advice might be for a novice. Let's say I want to get an agent that will reach out to all the meetups around and events around because I want to use our software, get them to use our software for an AI connector at those events. So how would you suggest doing that as a novice?
I mean, what I'd say is find like certain things that you find like pain points that you do a lot. Like if you think you're a sports fan and you do a lot of manual curation, right? I think like not go back on fantasy sports, but people would actually go and pay for friends of mine and managing their money for you, like a set, that could be automated very quickly with a machine and now agents, right? So if you have a chat that you do, maybe you're gonna have like finding on a meetup, but kind of a manual process of going online finding. You can say, get up to work on. So as far as how, I think you can actually, there's a lot of different agent technologies. I shared something from with SAP, but you can use different public agent builders, right? Just try something out, a lot of places in the trial, regular studio has a trial as well. You can see how do I build an agent, quickly, just giving it natural language, explaining what you just said, all the time, just aggregate them from go through the process of saying, this is what I want to do, build it, interact with it, and you can learn how to build agents by, but you know nothing, versus like, I think people might build agents like, hey, I can build an agent that would like, just like, I better optimize flight routing, but I don't fly a lot. If you fly a lot, then you would never know what flight or not is, but you're doing, you're just problem you care about. Now that you know that problem, you know the solution for it, you can build the agent, you can quickly double check and make sure it'll work. And I would say that's kind of the way I look at it. The what is now, you already have the what, how it can be 20 different agents building software out there, you pick one that you feel most comfortable.
Yeah, I'm not an agent person.
So what I would say with creating your own agents right now, if it's a relatively mainstream task, like the social media, inbox management, sales automation, you want to build one, you're building it because you want to learn how to build agents. I have agent as a service. I got about 10 agents that I license to run my social media, run my outreach,
they shoot this and that, and $20, $25 a month. And I've got an army of agents on a fucking build something like that because they're all being built. A friend of mine has his startup and he's got product manager execution. And so we have to be enterprise and teach you Jira automatically for you. So whenever I'm in a stand-up meeting and I'm like, oh yeah, that's slick. Oh, it updated it. Cool. And you have to go deal with the Jira thing. So, agents as a service is coming, but build one if you want to learn, or build one that is a very special workflow that you need to optimize. But if it's a mainstream thing, or give it another couple months, somebody will have one available. That's what I'm doing. I built several. I built some with Claude to go over my Be careful. No, I just
us this evening. I do have a follow-up question to his question that applies to everyone, which is what are some AI governance practices we can implement sort of in our own individual lives? Because I think with this talk, it's very easy to think that these challenges only apply to big enterprises, but we all are using AI tools in some way or the other. And then my second question is for Vikas. You mentioned in one of your responses that if you want to keep up, you need to invest and you need to spend, and the price tag is $2 billion. But I wanted you to touch on like timeline. Like if I said, okay, let's go down to Chase, here's $2 billion. I want a data center now. How fast can you give it to me? How fast can, one be built?
So in terms of building data center, if you have land identified, power is there?
I only have the money. I only have the $2 billion.
So if you have $2 billion, 3 months, you have OEMs, go to them, they will do everything for you. 3 months, 3 to 6 months. Yep. He said she got money. It's like,
You use agents in your own life. They bought a couple of commercial ones. I can tell you that my outbound email marketing agent used my own inbox and sending stuff and got stuck sending an email to the same person day after day. And the guy tracked me down on LinkedIn. He's like, why are you harassing me? Because, the replies to my agent, I didn't pay attention to it. So shove them off to another mailbox because it's using my account. I didn't want to see it. And I'm like, dude, you don't have unsubscribe built inside the tool. But if they replied and said unsubscribe, stop harassing them. Yeah, so I screwed up. Deal with guardrails for agents in your own life.
Okay, I think that you're talking about the bucket. Basically, in your case, it's generate page, and then you have to rule like don't send something to the same person every day. Like something like if you're getting responses, then maybe go on to if you get responses.
Do human in the loop. I didn't do observability. I did this thing and started doing outbound stuff, and I everything I said not to do.
But I think definitely guardrails are good. I think as a human, I think you know what's reasonable and not reasonable. I mean, you might not know like weird things that can happen, but if you say like you might not know like the case you described, but if you say if I'm sending an email to someone every day, if I'm getting email from someone every day, something is happening that's not normal, right? I mean, living doing anomaly type shit. Find out anomalies, take a look at.
Don't give it access to your Apple Pay.
Don't do that. Don't do that.
That's the biggest thing. No credit card.
If you want to make payment off of the guardrails, right? Anything under $5, sure, go ahead and do it. Maybe we're not really that's $5 either. It's like a small request, but it's like major request time on doing it. I think there's a lot of things you can do, both as a business or as an individual. Like you would kind of. I tell people that AI are like very smart children. I mean, they know a lot. Children that are smart children, but they might not be responsible. So the same way you control, let's say, what you do as a child, if you have not good children, they're going to pay $25,000 to buy on the online. Well, when I find you first, like you're going to $5 and you're saying, I think you want to say that.
Yeah, thanks all for being here. I have a question about observability. I haven't seen a lot of structure around this in the AI space. It kind of feels like, websites from 25 years ago where, people are looking for 500 errors and, nothing wrong, just like is a smoke alarm on kind of thing. and specifically like I think Walter talked on it a little bit, like workflows, like are they converting at the end? But do you guys have any more you could talk about that? Because I'm really looking for like a best practice or a way to know, are people using these bots and these workflows the way we're intending? Because people are putting a lot of money into this.
Yeah, I mean, lots of money to really offer this the intention in. You make it available, obviously, for customers who want to use it. But it's available to you to say, look, let me look through such anomalies from, like, if you're looking at like, if you're a e-commerce site, right? You may want to look at things like customers that are abandoning something very quickly, right? Maybe you look at patterns, oh, after people don't really make something forward, we're getting people who actually on such a very long time, they're not buying anything, or basically, again, the anomaly detection idea. Anything that's not normal, you just leave it alone. Anything that's not anomalous, I think humans take a look at it and see what's going on. The machines are very good at finding anomalies, but you should actually analyze an anomaly once you come to the machine.
Yeah, I'm going to share a little bit with Walter on. So yes, anomaly and outlier detection is the key thing. With AI, there's a couple of different things. One is things like session length that can tell you that somebody's trying to do prompt injection, so some things like that. Self-drift, I sort of mentioned that. There's an interesting challenge, and we actually don't have a solution. I'm working with a friend of mine, a company called Glacis, which is what we call longitudinal harm. And so in some of these cases, especially in mental disorders and damage caused to humans developing relationships with AI, the AI creates an alternate language. And so it doesn't say things like kill yourself, it says come home. And so how do you detect challenges with AI when the harm is built over longitudinal transactions and you can't say, oh, the stock word is kill, death, but it creates another language. And so we're dealing with how you actually do those kinds of observability with AI, because AI has shown that it can create alternate language to communicate negative sentiment to humans and get around those kinds of things. So there's a lot of work to do there, but basically it comes down to your normal thing, which is again back to my rant about basics. People are not instrumenting their AI for core observability and outlier detection. And yeah, you'll just start to see stuff. I have this phrase that I use, it's called learning loops. One of the main things to do when you ship your AI is to think, especially your first few models, your goal is not actually to have that major business objective. Your objective is that your organization is launching its AI learning. That's why observability and instrumentation is so important, because you need that fuel back into your development process, back into your models to improve. And the one thing I get really upset with engineers and companies isn't really that they cut automated deployment. You cut observability, instrumentation, you've ruined your ability to learn. And that is unconscionable, and that's the thing that bugs me the most. So learning loops. It's in my book. There are some questions here.
Yeah, so I have a question, which is actually a follow-up question to Vikas. So you mentioned something called OCP. Do you think that's something already available as a product? And then in which phase of the AI, the training or inference, which phase does it benefit the best of using this?
So OCP is not a hardware, it's a standard
Mm-hmm.
where all hardware has to comply with. So then agent doesn't need to care which hardware it's running on. It's just based upon orchestration layer or APIs. But OCP is the underlying basic standards which all OEMs and silicon vendors, everybody has to comply with, whoever is getting this ecosystem.
How is it different from the CXL memory stuff?
Oh, memory is hardware.
Okay.
So they also have standards, like memory has their own standards, which is just a communication, one standard to talk to CPU or inter-memory, right? OCP is a big compliant to talk to backbone, to talk to other node, to talk to network. That's a complete suite. Memory is one part of that.
Okay.
It's a full standard for AI infrastructure.
Okay, cool. Thanks. Yeah, I think I can do more research on that. Another question maybe to the folks who working on agent. I think these days we're trying to do this service as an agent. So if we're gonna build an agent around our service, I think we're likely run into a situation that like human language when they transfer to or a a query was or something like that. I think we lost some of the context, that the hidden context maybe in that original request. So even if we have the source of truth as a database or whatever, so how can we like address the difficulty when we actually present the data that the customer actually wants? Because when they sending requests from a natural language, some of the context is lost, and then that will result in the results accuracy when returning. So for some of the, if we just do chatbot for normal queries, I think it will be fine because we know that it may be accuracy um, in the result that is not 100% accurate. But then for some of the high critical query, like for example, security data or whatever, that will require 100% accuracy. I wonder whether SAP or other companies who are doing things like developing agents, do they have any experience or lessons learned from this?
I mean, I think again with the human in the loop idea, you have classifiers and you have queries coming to your chatbot. So there's simple questions like what are the store hours, your refund, with the refund policy, right? We say, hey, actually, bought a ticket, my flight got delayed, the store is closed today, and it gets very complicated. Those are the ones that need to actually get funneled to the human operations, right? So I think that having a hybrid approach again is really important there because you have a classifier, you do your best to not guess if it's good classified. And even if it's sometimes the machine might be off by saying store nine stuff, it doesn't respond with when I turn response saying, I wasn't asking what the store are, so I was asking if it's a special hour to Thanksgiving or a special hour. Now it's getting more complicated question. Initially it's like store hour, easy question, but it's like no store hour to special occasions, then maybe that isn't documented properly. So those type of things again might need to be brought to a human or need to be brought to an engineer processing. I think that's the best way. I mean, the worst case is a false negative, where basically you actually misinterpreted the customer and you respond and you're done. You seem to be done. But oftentimes there's an opportunity to have a second turn, right? Say, hey, look, you didn't answer my question. At that point, you can sort of tell, just like I think the early days of the telephone automated services, the algorithm detect anger or frustration in the customer's voice. Once you start feeling that and you realize answer the question hasn't been answered properly, this is when the best way to have it. Like you said, if you even though some cases aren't important to others, like any customer service example, you want to be able to help the customer 100%. You want to be like, oh, this is not important to 80%, that's fine because then you lose 20% of your customers, right? So I think that having some escalation paths and multi-tier processing, which kind of human layer is still important.
Thank you so much for your time today. My question is regarding the number of the cases that we saw. I almost feel like that there is no winning in those cases. Like there is like specific areas that it might be wiser not to apply the AI agent, like almost. Then my question goes to like, what is the hopeful way of to have a preventative control on those cases? Because the control that I heard is like the one at the time or before the deployment itself, before the publishment, what kind of testing that we can do. Once it go live, it's for the operator to be liable for it. And then we can't really win for the all the fraudulent or injection cases versus the million of the users in the world. It would be very difficult to defeat in that stage already. Maybe at the later stage, we can do the deduction, we can go for the settlement, we can start building the cases going forward about, hey, like those are the required processes maybe going forward with the human looping in. It's going to take some time to set up a rule around there. Then for the next probably 2, 3 years, while everybody is trying to figure out what is the hopeful prevention control that everybody can think about.
I mean, a lot of what's happening with agents right now is that, again, people are largely vibe coding them. They're telling them what to do. They're not doing a good job at telling them what not to do. And I mean, we would never create a system account and give it more privileges than it would need. There was the case not too long ago, a guy was using Cursor, and he was using Cursor to help manage an update, and would needed to change permissions on a database and couldn't figure out how to do it.
but he had written code so that the agent couldn't delete the database. But the agent found a cached credential somewhere in the repository that allowed it to delete the volume. So it deleted the whole volume, and it recreated the volume, and it recreated the database, and it tried to populate the database with information again and tried to cover its tracks because it somehow realized that deleting volume was actually not a good thing to do, and it lied. So, you know, you need to that's so the thing is, you know, scoping your agents correctly to least privilege and preventing them from being able to do those kinds of things, you know, credit cards, like Walter said, a $5 transaction and not more than 25 transactions in a month. Because you pay, I just did $1,000,000 transactions with the same amount of dollar transaction. That's the same $5 transaction. You know, so thinking about how to do that, we call that a lot about the blast radius and how do you design your agents and your things to do that. But you know, when you're vibe coding, everybody's all excited, like what I got it to do, not like what I stopped it from being able to do. And so it's just fundamentals. We're just dropping the ball because we're rushing because of the whole FOMO. Fear of missing out. I got to get some of that there AI because the board is telling me I didn't ship AI and I'm going to get fired. So I released an agent on the world with a big free cracker. Like you know, Microsoft technology is coming fast. Agent 365 that Microsoft had built. There's some good stuff there. So there's some things coming along, and so you need to be able to, especially with agents, you got to be able to manage the permissions and manage the boundaries of your agents.
Yeah, and so I like, you know, like example you gave is like the child, right? I mean, the bot had to cover its track because it knew that it was supposed to do that. So in the same way, if you don't give a child correct instructions on it, you can find what's going on with it. So provide instructions to the policy fairly to the agents to do the best you can for it, right? If I coding in school, you know, it's fast, yeah, you need to actually make sure it's doing the right thing you want to do now.
Yeah. We'll take last two questions and then you can continue to have your conversations with the speakers outside. Yeah.
Fair. I had a question, and you kind of touched on this with the longitudinal harm, and we've talked a little bit about it with like the human in the loop pattern. Is like what we're all kind of on this curve where it's ramping up incredibly fast. We're all trying to keep up. Things are changing constantly, and we spend a lot of time trying to automate away all of the cumbersome tasks and everything else. And we've created frameworks for putting guardrails on agents and guardrails on like our code base, but like are there any frameworks of like guardrails on what I guess as an organization, like is there anybody working on guidance of like what should and should not be automated? Or I guess it came up because the human in the loop pattern in theory is a great idea, right? Like you are leveraging a person's judgment. And a judgment is a hard thing to automate, especially in unpredictable models right now. But its implementation is more of a like scapegoat setup. Like you get 2 seconds to make a decision, you get no context, you get no reference point, like you're churning through things as fast as possible to be that human scapegoat in an automated pipeline. Um, and like is there there's a lot of talk in startups and stuff about doing things that don't scale. Doing things like going through inefficient process for the value of like the relationship and the value of the customer and stuff. I'm just curious, working in the compliance space, is there anything that um defines any kind of guidance in terms of the opposite? Not what we're automating, but what we're not automating?
And I think it's funny. I think part of for like, readily set scenario or lower risk scenario. I think you start there. I think that the guidance would be like, for instance, marketing is email marketing or spam. If you like that's a very low yield. People actually send it's okay. It's been hard used to send me stuff all the time before agents came around. I get maybe 100 emails and I almost never respond. Right? If you can build an agent that actually helps provide more better targeted methods, right? Send them out. The harm would be that they still don't respond. I mean, like, it's already a low yield process. You can make it yield a little bit better, you win, right? Versus like the opposite of like if it's sending an email to a CEO or whatever, you should have processes where you don't want to take very high risk decisions first. Start with lower risk, gain confidence, and then do more. I think it's like we can't look into the future, but we can look back where when your internet came about. I don't know if you remember your first online purchase. Like I don't know something on like credit card or not. But I wasn't buying a $5,000 item. I was buying like a $5 right, and keeping a full plan, making sure it's fraud and I just set on a credit card. So I think it's like you can do things like that can help you with bulk mail. Have helped you write like if you do 100 recommendations for students you teach for an education, and I know you want to do your best job, but having a machine do it's fine because you might not be able to do better yourself anyway. Those type of things are lower risk versus like you want to have it balance your checkbook and make stock purchases, probably not. You want to make life changing decisions or medical decisions for you, probably not. So basically, look at things that are to lower risk. I mean, you can determine what's risk, high risk, or low risk, your personal life, within space, and then focus on those things first. Gauge trust yourself. Does this work? Does it not work? Did I not work? Did it not work because I didn't ground it properly? I didn't ask the question. Over time, you kind of refine that, and then over time, okay, these spam emails I'm sending are actually getting better responses, but they're very targeted, and targeted levels are approaching, let's say, a certain level or we can now send messages to colleagues. And then once you do that, and it gets even better level, that can actually make you more important colleagues, whatever. So you have this idea of, as a human, you have a mental threshold of how close it is, so you can see kind of work your way into that. That's how I think.
We could say one of those that would have been one of my things. I'll channel Bob real quick. His comments is he because we talk a lot about AI for good, and he likes to use this phrase, the garden of humanity. What do we think about AI as we get further into it as humans? And what do we think about are these innately human activities that we don't want AI to take over? And so, while I agree with where you start, I also wonder where we end. What are those things that we reserve as exclusively human? I don't know what that line is either, but I agree with Walter. Let's start small. And I see Padma's right there, but I'll tell you one quick little silly story. So don't do this one. I was promoted in the meeting one time. I had a note taker in the meeting, and everybody was talking about this great idea for something that they wanted a new website to do. Was tuning out. And this is really stupid. So I stopped my note taker and took the transcript. I fed it to my AI. I'm like, what are they talking about? It's like, oh, they're trying to design this product. What are the requirements? And it came up and it said, here's the list of requirements. I'm like, oh, can you turn that into a PRD? So I turned it into a PRD. I'm like, oh, that's pretty good. So I took it over to level. I said, can you turn this into a website? And turned it into a website. I came back to the meeting and I did the demo, and everyone was like, oh my God, can you ship it? So don't do that because that's just a really fancy miracle. Wow. Just thought I'd share that with you because that's one of my. I literally did that, and I was like, I wonder if I could trick people into thinking it was great. And yes, they wanted to ship it.
Cool. That worked.
You want to take another question? We were wrapping up.
Maybe one question, yes. For you, yes. Actually, I'm interested in going to late, but sometimes people enjoy coming to you close and then knowing you guys. So that's why I wanted you.
Hi, I have a question for you. AI and ethics is really something that I'm very passionate about. I feel that the government is lagging because I come from a regulated industry, which is a utility industry, and the government's really lagging behind regulating it. And I'd like to write to them, but I'm not quite sure what to ask. What are some things that we could potentially ask our elected representatives to do in the field of AI regulation?
So, what can we ask our regulators to do? I mean, that's a good question. I'll actually have to.
Sorry, can I just do a follow up on that? We talk a lot about human in the loop, but there's a lot of companies that are laying off massive amounts of people. So, human in the loop is just a luxury at this point because people are being so overloaded. There's really not enough enough bandwidth to be able to do the human in the loop. So, what are your thoughts on, say, mandating that for regulated companies, for X number of AI agents, you need to have this many humans or something along those lines, maybe? I don't
Well,
know.
it's an interesting thing. So you and I have to talk offline because honestly, like I said, I've been studying anti-patterns quite a bit, and I'm not working as saying what the actual solutions are. I just really enjoy finding these screw ups. But yeah, what are the regulations? I do know that one of the things we do talk about is um, attestation and tracking how the AI made decisions and the explainability. And so one of the challenges you have in AI with insufficient instrumentation is people aren't logging what it was thinking when it made a decision, what version of the model it was using, what version of the data that was used. So that leaves you wide open when it does make a mistake to not be able to figure out how to correct it. So that's one of the things. Human in the loop is an interesting thing. How to scale that? Can you do that regulation wise? You have to do some things that I have to tell you. I don't quite have an answer there. But yeah, I'm glad to spend some time on it. I've just been having so much fun doing my scary stories.
I'll just add, if you reach out to lawmakers, I would just tell them to reach out to experts like yourself. Like the difficulty, I think, is sometimes lawmakers are expected to make decisions. I mean, not just about AI, about everything. I mean, they're generalists that have constituents that need that to be represented. I think that experts like yourself in the industry can help provide information to your representatives to make sure that you get informed regulations or control. Because I think that and you just tell them do something about this problem, they'll do something. It might not be the right thing, but if you kind of inform them and say this is what I recommend, this is why, explainability from AI to lawmakers, you can help them come up with more reasonable regulations. Because I don't think I'm not saying we shouldn't regulate, but I think we should only regulate in a meaningful way, right? And if people who aren't informed are making decisions, I'm not saying they are, but they weren't informed. The decision might make. So have them trust the expert, you volunteer your time and
Well, that was better than my answer.
Again, thank you again, everyone. But July the 9th, Robin Sutara, Databricks, she heads the AI enablement. She's going to come and give the keynote, and we have other excellent speakers from, I think, Splunk and Meta, and there are other companies. So please do come for the July the 9th one. By the way, Ken, I'm a classical dancer, but I today in you gave all the kinds of moves while you were giving your speech, you know. So he he would be a potential good student for myself. Anyway, thanks again.
thank you.
Thank you.
Thank you.
Thank you so much, all the speakers and attendees. If you can give us one more moment, we can all take a picture. That would be great.
Please comment, repost. Only then we'll be able to, it will make our life easy. That's a small help. Thanks.
Oh yeah. Okay.
Set up Jaipur for
So you want to have a second, right?
Sure.
You want to get a picture with us?
Oh, yeah.
Yeah.
First, yes. You go first.
Okay.
You have to tell which one is
Yeah.
my time all
Okay, can we have everybody, all of us join?
Take it.
Anybody that wants to be in, come on in.
Thank you so much.
Yeah, we do agree.
Yeah.
Everybody up here.
Sure.
You're from Discovery. About to be
Yep. Yep. We're from Rutgers, so chat with you.
keep for I shouldn't eat him. We keep calling for tea, but food.
In fact, for me, what is the Helvetic I think I call that way.
That way.
So you get a bit more black kind of.
You can keep coming in.
Thank you.
You can just stand there, it's fine. Yeah. Yeah, thank you. Should definitely